Well, hello everyone. Now you can hear me. Sorry for the delays and everything because we have been troubleshooting audio, troubleshooting live sharing and everything. And yeah, this has been a madness. But now, yes. I just unmuted myself and all the stream now. So now should be music in the background, like when I stop speaking. And yeah, I think we have everything ready. Well, Olgi, say hello. I don't know.
Hello. So yeah, we are doing day 8 now, I presume. I think I'm actually going to open up your stream after all. We'll keep it muted, of course, but just seeing it will be helpful, just being able to see it.
Okay.
Can you share the link in your Stream Connect?
The link for what? Sorry. The
Your
link
stream.
isn't there. I just copied it before starting.
Yep, seeing now. Okay, let's see.
Okay, so for now, I want to make the copy for the in9 so I do not forget about this.
Oh, we have a viewer.
Yes, we do have a viewer. Yes, that has been patiently waiting. And now he's a bit gone because he has to do something else. But yeah, he's listening.
That is much appreciated. And that actually gives another reason to have your stream open, because I cannot read Twitch messages on Matrix.
Oh, yeah. Create template for day 9. So don't forget about that. Okay. Okay, are you ready?
I am ready.
Okay, so let's begin with the task. So we have the treetop treehouse. I'm going to put in the chat in case anyone wants to follow along. Or maybe for you, okay, if you want to open it yourself.
I have it opened.
Yeah, so treetop treehouse. The expedition comes across a peculiar patch of tall trees all planted carefully in a grid. The elves explains that previous expedition planted those trees as a reforestation effort. Now they are curious if this would be a good location for a treehouse. First, determine whether there is enough tree cover here to keep a treehouse hidden. To do this, you need to count the number of trees that are visible from outside of the grid when looking directly along a row or column. The elves have launched a quadcopter to generate a map with the height of each tree, which is our puzzle input. For example, this 30373, blah blah blah. Okay, that sounds good. Each tree is represented by a single digit whose value is its height, where 0 is the shortest and 9 is the tallest. A tree is visible if all the other trees between it and the edge of the grid are shorter than it. Only consider trees in the same row or column, that is, only look up, down, left or right from any given tree. All of the trees around the edge of the grid are visible, since they are already on the edge. There are no trees to block the view. In this example, that only leaves the interior 9 trees to consider. Okay, top left 5 is visible from the left and top. So yeah, this 5 over here. Yeah, okay, that's understood for me. Moving along, with 16 trees visible on the edge and another 5 visible on the interior, a total of 21 trees are visible in this arrangement. Consider your map. How many trees are visible from outside the grid? Okay. So, did you understand the task?
As always, no, I need to read a couple of more times.
Okay, give it a read. I'm going to copy this into our sample input.
Okay.
Close all files to avoid being confused between
It's enough tree cover here to keep a tree house.
To run day 8, sorry. Day 8, part 1, sample input.
So the sample input is a top-down view.
Yes.
Okay, that is cool. I like that. Around the edge of the grid, I didn't catch that. What is that are visible from outside the grid when looking directly along a row? Determine whether there is.
So what is the problem? Where are you lost?
From what position are we looking?
From outside, from any of the possible left and right, up and down.
Okay. And we need to find like trees where the treehouse will never be visible?
No. We only have to count the number of trees visible from the outside.
Okay, so if we look from down, then basically only 9 is visible.
From down? From which?
Like in the sample input, in the example, when we look from down at the 4th row, only the 9 will be visible.
If you look from right to left on the fourth row, yes.
From right to.
Okay, you are looking at my stream as well, right?
Yes.
Okay.
I put it up on the second screen, so I can always look if need be.
Okay, so let's give a better explanation. So we have the following thing. Okay, so it's 307 35512. Wow, 373. I messed up already. 5332 3549 5390. So this is a 3, this is a 3, this is a 6, this is a 2, this is a 3. Okay, so those are looking positions. Let me center this so we can see.
My question is, like, if we stand at the square 10D. Oh shit, do we need to consider all of the 5 squares in
Yes, all of them. So
all of them. Fuck.
So the thing is that if you're looking here towards the left, you have 3, 7, and not visible, not visible, not visible. So from here you see 2.
But like, do we have to consider positions from that are not straight ahead of us? So example, we stand at 10 at 10C. Do we have to consider whether E2 is visible?
E2? No. You can only stand on those positions here, and you only look straight.
Okay,
straight
then it's clear to me.
Okay. And then the problem is that when we say if the tree is visible, we don't only want to count the number of trees from here, because for example, here is 2, here is 1 and 2, okay? We don't want to add those together, because what we want actually, from what it's saying, we want to mark them. So we know that the outer ones are always visible, because the first tree is always visible. That's the reason. There is no possibility to make those trees non-visible. But then the idea is that, for example, this tree is visible from here, from the right side. So that one, we need to mark it. And then from the left side, this tree is visible. So we mark it. Okay? Yeah. So, and we continue, and then basically it is asking the problem, how many trees are visible? So how many trees did we mark? This is the thing. So from the right to, so for example, here, left to right, you only see the 6. Right to left, you see 1, 2, and 3. Does it say what happens with 2 equal? Yeah, so it is visible even are shorter than it. So with this equal height, you only see the first one. So you see the first 3, you don't see the second 3, you see the 5. Okay, and then 3, this one you don't see, this 5 you do see, this one you don't, and so on, okay? So, yeah.
So the first part sounds really simple to me. My first guess would be to have an enum for each tree, and then somehow pass from the input how many trees there are, by default assign them all to be...
We will see. We will see. So you now understand the problem. Now let's begin. Now let's begin. So the first problem is we need to pass the input, okay?
Yes.
So passing the input should be as simple as for line in contents.lines. We want to trim this, but I cannot trim here because this gives an iterator. So filter x is not empty. So that should gives us yeah, here you are. Okay, and I can see here the different lines. That is nice. Next step is basically we need to go character by character, convert it into integer, and that's kind of a vector. So line chars to get the individual characters, map, so that we want as an integer, x ooh. Why doesn't like my... Is this something special? What I'm getting here? Chars, that's an iterator over char. And this map, what? Oh, come on, I want you to tell me. Okay, let's write it. Oh, or now is this was to parse. Oh, yes, because parse is for strings. This is not a string. This is a char. That's the reason. That is the reason. 2-digit. That's it. 2-digit. 2-digit radix 10.
Can you remind me again what that radix thing means?
Radix is the base. So base 2 is binary, base 10 is decimal, base 16 is hexadecimal.
Okay.
Yeah, so that will give us options. And if it's not found a non-digit 3 hecht. Okay, and now this one to collect. Let v vec. That should be a vec of use32 from the signature of the function, I think. Now let's debug v.
Can you copy your puzzle input into the txt file?
It's in sample input always.
No, wait. No, sample input is the example. I mean the actual puzzle input.
The actual puzzle input. Sorry, I didn't grab it. 1 sec. Get your puzzle input. Copy. Paste. Save. Now it's there.
Thank you.
I see 99 lines of 100.
Yep. And that's a bit more than the alphabet has.
Yeah, I don't see why is that a problem. You might be you were thinking maybe of something else. I don't know.
I was kind of thinking of assigning IDs how they would look like in an Excel chart. Position IDs.
So let's see. We need to store this in some way. So the tree map, right? On a struct of tree map. I don't know if I'm going to need a struct or not, but I don't know, why not? So the map, because it's basically just a type, a vector of a vector of a U32. Actually, we don't need a U32, we just need a U8. This feels...
You are considering a U8?
Yes, I do, because I'm going to store 100 times 100. So that is 10,000. And prefer, like, it's just 1 digit. There is no way to overrun that, and we are going to do only read-only. I know that is not very like me, but
yeah.
So let map a vec of U8 is just a new vec. Okay, it's just a new vec. And now for each line we just push to the map push. Can you make that mutable?
The map?
Yes.
Let mut map. Yes. Hey, I did something. I'm helping.
Okay, now the problem is representing this, because if I do if args debug, so I have the debug here with arguments, so we can enable it on console. To do here println. So the problem is that if I do map, print it here. Let's execute. I think we are not going to like how this looks. Well, I mean, not bad. Not bad. Is suboptimal, but not bad. We can do something. I'm going to teach you something. So, if you want to customize this, so let's do mod map. Instead of a VQ8, we make the tree map. We can derive here the bug clone, and we can derive default, which is to ease on how to create. So we want to create a new one. I can just do tree map and do : default, and that will create it empty automatically for me. And now this will be, instead of map, tm, tree map, map push, and tm. Okay. So far is the same, it's just that we have now a struct. But now here, if I want to customize how the debug looks, can do implement debug for tree map. And in here I can do implement missing members. Okay. And I need to remove the derive. So if you put the implements debug, you need to remove the derive. So because the derive does the same thing. Okay. So this so far should do the same. Yes. Debug struct, tree map, field map, self map, finish. Yes. This we can do. So f is a formatter. Oh, this returns. Aha. So can I field name and value? This is strange. Okay. Okay, so this is do it automatically, but we can just write format arguments, format args. Okay, or just write. Let's see. Write the string. Okay, let's try. If I put this, now I should write just test. Okay. And do this. And now so let's get a line, a row. For row in self map, and I can do can I put iter? Okay, that is because it returns an error. That's it. I can do like that and like that. Let's see if that does work. Okay, it prints it's 1, and now I can do \n.
That looks nice.
Okay, can put 2 spaces on the left, so it paths to the right.
Can I do that in C++?
But C++ doesn't have debug traits Yes, you can create a function in C++ that a class prints itself, but it won't integrate with the rest of the language.
Won't integrate with the rest of the language.
Like you will need to call it manually.
Just do a method that has a similar syntax then?
Yeah. Okay, so at least if we pass the real data, yeah. Oof. Yeah, if we pass the real data, this looks a bit horrible. So if we do for our row iter, we map it back into a string, x to string, and then we yes, then we need to, because row.join does that work? Or join does not work for as expected. So we need to convert it into string. Iter map into string. Collect text maybe. That is vec something, and then what happens if I print this instead? Okay, that's a vector of strings, correct. That's vtxt, let txt is vtxt. Now join should work to join into a single string. Yes.
That looks good.
Okay.
Still a bit narrow on my end in the terminal. Like, I don't know why it cut off after some lines, but
yeah, depending on your font size and the width of your screen, but yeah.
I think it actually has more to do with it being live share. Because the amount of characters in a line is exactly as long as...
Maybe it's only 80. Maybe it only communicates for 80 characters wide.
18, cool. You say?
80, x0, maybe. Because 80 is a common...
it's even
value.
Less.
It's even less. I have no idea. Anyway, we will not be printing this that much. But yeah, we got the data stored. So now we need
3 Eno?
We need the same shape to store the same thing, but like it's just Boolean. We are just counting, so it's just either 1 or 0, so true or false. So it's the same vector shape, but it should be all to false, so we can count them and mark them in the right position.
But wait. Consider how many trees are visible from outside the grid. I see. So, okay, for the first part, then you would only need to count the true or false values.
Yes.
I'm wondering about the second part, though.
Don't worry about what you cannot see.
Okay.
It could be completely different. So yeah, now the problem is that I need to do the same shape again.
Is that a problem?
Yes, because this shape, I'm thinking, should I count the maximum, the number of lines and the maximum of columns and just do that? So like, store here, rows, usize, calls, usize. Yeah, I guess so, because I will need that for computation. So then I will need something that...
Couldn't you just rows, usize, calls?
So rows is just, this one is easy, it's just map.len, self-map len. That's why it's not completing for me. But columns, this is a problem. Columns should be the maximum, or don't need to make this super safe. We can just go to the first row, and assume there is one. Why you don't like me? Why this? What is this giving me? Get... Why? Cannot index into... sorry! Maps. Map. Self rows is a number. So stupid. Okay. Now, in here, I can do... F debug map set tuple debug struct. No, I just I want to use some of these neat things, but making it work is non-trivial. Yeah, let's do it. Let's do it manually. It doesn't matter. One space. Let's say rows is debug for self rows, and calls is self calls. This compute size needs to be executed after reading the data. Compute size, and now we should have rows and calls. Okay. Now I can see exactly like the real data, 99 rows by 99 calls. Okay. I don't know. That sounds good. So now I can store the data into a different place. So tree visible. Yeah, I'm going to implement debug myself as well. Map rows and calls. And no. So what I'm thinking is implementing here something to create a tree visible struct from a tree map. I'm not sure you're following me. So the idea is that the tree map has already the size, and we could. Are you listening? Are you
I
there?
am listening, yes.
Okay. I was wondering, like,
There just isn't much to do for me at the moment, so.
yeah. So the idea is that we get. Something typical here is creating a function that says from underscore and the other type, which is tree map. Okay, and
Hold on, I was looking at the stream. I probably should look at the shared screen. Which line? 42.
42, yes, I'm on 42. So the idea is that we pass a tree map. And the idea is returning a tree visible from it. It's better to do so it doesn't error out. Because the tree map has the rows and calls, I can use that already. And now the map, this will be Boolean.
But I was wondering, what I meant to say earlier, instead of making an additional tree visible, couldn't you just make a tree map that contains a bool? Like the map would be a tuple of a new 8 and a bool, and first the bool would be all set to the same value.
Yes, you can. Yes, you can. But I don't know. I think that different type is going to make things clearer. That's true that we could store everything in the same map. We could go that way. I don't know. You want to try that way instead of going this way?
I think if I did this program myself, that's the route I would go. Yes, and I would also store some more data.
So then let's put names, because I like putting names on stuff. So tree data is hecht, which is the u8. Visible is a bool, and then we can add the data here. So now this tree data can go here and derive clone default. And now here we need to output that tree data, and now it's clear that this is height. Wait. Why was doing you? This is the debug. Sorry, this is the debug. My mistake. It lags that to string. This is just the height. Okay. Here, when we push this, we push the tree data of height.
It doesn't do an out scroll. That is a bit unfortunate.
And default.
Is there a way for me to enable auto scroll?
I don't know how. I never used
Google
that.
Live share enable auto scroll VS Code. How do I? Oh, disable auto scroll. That sounds like it can be enabled. Explorer auto reveal. Okay, so inside the JSON, huh? Let's see. Control-Shift-P. Open user settings. Oh, David, where are you? I cannot see your facecam anymore.
Yeah, sorry. I'm talking to Lucia. She's asking about dinner. Not clear what to do here regarding dinner. So I'm just discussing with her right now.
I could try to do a bit on my own, while you are gone.
I mean, if you want to try,
I'm up for it. I'm not sure what this will lead to.
okay, we can try
I
that.
just have to see. Cannot edit the terminal in read-only mode. Anonymous. Okay, never mind.
I can enable for you
Okay.
and execute. One sec. I just want to clear out this. So map push factory data. This backline. Oh no. Okay, this is the row. This is the row. So here. Was placing it in the wrong place. Sorry. So yeah, that goes here. Bingo. Okay, that will do the same thing, but now the contents are tree data type.
Nice.
Okay, so do you want to try it yourself, and I'll leave you on that?
Yeah. When will you be back?
For now, let's say 5 minutes while I discuss what do we do for dinner, and then I'll tell you back.
Okay, I suggest that when you'll know, maybe add a TXT description to your stream, telling what's going on.
Okay. So you can, I mean, you can be here on stream, so you can do the stuff. Okay. But I mean,
I still cannot edit the terminal in read-only mode.
Yes. Make red right. That's it. Now can you try?
Okay, I'm gonna try. Cargo run. Oh shit, cargo run could not determine which binary. Yes, of course.
Yeah, you should be able to sample. Yes. So yeah.
Okay, thanks.
Okay, so you have dash p1 for part 1, dash d for debug, dash s for sample data.
Does the terminal look weird on your end?
No, it looks okay.
Something is bugged here, but I can use it.
Okay.
Enter.
Okay, yeah. I'll leave you at that.
Cool. Then have a good talk and maybe dinner.
Okay.
Okay, so let me try to get an overview. We have the height, which is U8, and the visibility, that is the bool. The position already follows from the tree data inside vector. So, okay, that's probably not what you are meant to see, but it will do. Tree data. What are we printing out now, actually? If args debug, print ln tm. What is tm? tm for line in contents. tm tree map. Okay, tree map. Implement. How many print lns do we do? Print ln, only one, args debug. If args debug, print ln. So we do a debug of tm, which is a tree map. A debug of implementation tree map. Yes. But I'm confused. It's only printing a U8. It's only printing a U8 here and not the bool. Why is it not printing the bool? Write format, rows, calls. TXT, VTXT, TXT, vec. X height. Okay, so it only prints the height. Yes, I would like to make it print the state also. I would like it to make the state also. Let VTXT. So which type does VTXT get from this? Can you tell me? Rust Analyzer? Shit, is Rust Analyzer even working? Do we have a mutable variable here?
Hey, back. Oh,
Welcome.
oh crap! I left the wrong window in the
Yep, I
stream.
was commenting on that.
Okay, so I have around 10 minutes, I guess, until Lucia makes the burritos. Because
Okay.
There is not much to do on what we have in the fridge. And after that, I'll go for dinner.
So I was just trying now to follow your debug printing code. It does print the... I did gather that it prints the height of 3 data, but not the bool of 3 data. And I would like that information to be available also.
Okay. So I was going up in the stairs and I was thinking exactly about this. Exactly. So I was coming up. I had already an idea in mind. So I will put here height. So it looks pretty. And now copy and paste, because we need to iterate again. We want a complete set, because it will not make sense if we put both things together.
Okay.
Then visible, instead of height is visible. But instead of toString, this cannot be toString because this is a boolean. toString will return true, false. We can try. Will be horrible. Yes, false.
So can I share how I would like to do it?
Yes.
So but wait. No. It does 2 prints now. That is not what I meant. I meant hold on. For row in self.iter.
I mean, if you do it all together in the same line, it will not look good.
So I wanted to have it number bracket state bracket close next number. Maybe with a dash in between to differentiate more.
Yes, and I'm saying that it will not look that good.
It looks better than false, though.
Oh yes, but I was going to fix that. Oh, come on. So
Still, I'd like it to have it visible on first sight.
If visible, 0 to owned, else
I think I already know what I will try to do.
Okay, you want...
I will focus the time while you are having dinner to X to...
Something like that was what I was thinking. But what you want to do will be up in the 3 data. I guess that we could implement debug or display a display implementing display here so we can print the display one after the other. So basically converting it to display. That's what you want to do. You understand what I mean? So here, line 55.
55, let's see, 50. I am at 55.
Okay,
Line
here, implement display. Come on. Yes, for 3 data, implement missing members, and then this is similar to the debug. So basically, write a string, whatever you want to do. This is, let's see the others who. Yeah, write a string or write format. So similar to the other. So here you can do the height, for example, dash the visibility. Okay, so you could do self height, self visible. Maybe, I don't know. We will change this later. Just to see what it does. So with that, it will put first the height, after that the visible. It will be still true false, of course. But then the advantage is that we can do. So let's put another one to just see the full map. Instead of x height to string, just x to string. To string calls the display. So here, line 96.
Yes.
If you do directly dot to string of the struct, this is the 3 data. X is 3 data. Okay. If you do dot to string, this calls the display formatter.
Okay.
That we just implemented. Okay. So not only works with print, you can also call it via toString and other methods as well that I don't remember, but they are there. And we run that. We should see map at the beginning, map, and we'll see this 3 false, 0 false, 3 false, 7 false, and so on. Now we need a better way of representing that for the toString method. The display trait needs a bit more care than this.
I would just have the first letter in capital, like capitalized. The number outside the bracket, the letter inside the bracket, and the dash to separate the trees. That's what I would do.
I don't understand which letter do you want in. There are no letters.
Hold on. I'm gonna type in the terminal. So this is the example of a tree. And this is the next tree. Can you see? Bottom of the terminal?
Okay. Yes. Okay.
Your viewers cannot see. Oh, they can. It's.
Yes, it's in the terminal. It's visible in the stream, yes. So we can just copy that into a comment. So what you are saying is something like, we can put just a space or something. We'll see. So number and visible, and then visible, let visible equals match self visible, and then auto fill match arms, and this is T, this is F, to owned. Actually, I don't need to do to owned. I don't need to do. And then this is visible. Right now they will be just together. and the spacing probably needs to be carried. Let me see. When we do the join, in the join line 93, when we join them, you want the space dash space. And now that's what you're saying.
Can you run again? Yes, that's what I want.
Okay. Now we have to see how to attack this problem.
But wait, hold on. Function main height visible. Okay, so we are having everyone false by default.
Yes, because as we want to count them, we have to assume at the beginning there is all set to false, because the ones that we visit we can set to true. And afterwards, you will have set to true the ones that we need to count.
Good.
The other thing you can do if you feel blocked that this is complex is, for example, creating a method here in TreeMap, to count scene trees, which is self and returns probably usize. So basically, if you want to try to do this yourself, this should be more or less simple, which is basically visit self map and count self map x y sub x dot visible equals true. Oh, I'm being called for dinner.
Okay, yeah, I've got a stick. Do you want to put the text up that you are AFK?
No, we'll put something in the chat and that's it. No
Okay,
worries.
yeah, that makes sense. I will see if I can do something, and
yeah, the constant trees, I think this is quite contained. If you want to try it, higher chances of success. Anyway, do whatever you like. I'm gone. You need to be running.
okay. Have a good meal.
Okay, thank you.
Visit self.map account. Oh no! Oh no! He switched it again. Well, okay, good. Thank you. Self.map tree data. Count scene trees. For Okay, let's do for row in the fact that there are vectors inside vectors. That is a barrier that I don't know yet how to cross. How to make an iterator that will go through each line and each row appropriately. Map YX. Okay, hold on. For row in self dot struct tree map. Tree map is TM, right? But wait, self in this context is the tree map. So self dot rows. Yes. But it seems to disagree with me here. usize is not an iterator. I'm blocked. I'm not running my usual VS Code instance, so hard for me to look up my previous stuff. Wait for row in. Oh, hold on. Self dot rows. And we do 0 dot, or do we do 1? Mismatch types, expected usize, found. Huh? Ah. 8. Okay. Wait, why are we returning a usize? Why are we returning a usize here? For you know, the 8 has to stay here, otherwise it will complain. The next thing I have to do inside the scope, I think, self for pos in self dot row calls. In self dot map. Wait, what is okay, now column. What? Let's see. What is this? This is line 80, column 2. Column. So row is equivalent with line. Row is equivalent with 9. Okay, so we go down first. But I don't think I actually want to go down first, so I'll do call. For call in 0 to self.map. Call I cannot, usize is not an iterator. Dot visible, of course. Dot visible equals true. Self is not declared as mutable. Okay, I'm gonna leave that at here for now. I wanna go AFK for 2 minutes. And when David will be back, he can comment on whether my general idea goes in the correct direction or not. So yeah, AFK for 2 min. Okay, I'm back. Can I verify this somehow? Let's see. I'm gonna scroll down. Print ln tm. Tm compute size. TM count scene trees. Oh. That makes sense. Ampersand mut self. Although I still don't know why it's returning a U size. Oh, wait, because... yes. Anyway. For now, we are not counting, we are only inverting. Yeah, in the terminal, everything is F. What is it now? TFFF. TF.
Hey, hello.
Hey, welcome. So I did try a thing, and it didn't work. It didn't work. First column, everything is T, and everything else is an F. So what do you have to say about my idea?
0 to... Okay, let me see. Is this code unfinished, maybe?
Yeah, definitely. I was just testing a thing. But I mean, hold on. True. Yeah, no, it's false. It's false. It's not just unfinished, but actively false.
You are again trying the whole thing. That's not what I asked. What I was asking is like, if you have visible already set to true or false, to just count them, not to compute the whole thing.
Okay. So you meant
Yeah, now I'm
you
seeing
meant me
the
to
code.
skip the conversion thing?
Yeah, that was what I intended, just so you
I
had
see.
something simpler. But
My bad, probably, but wasn't clear to me. Wasn't clear to me that you just meant me to count the trees. Oh, that's unfortunate. I think I could have done that, but oh well.
okay, so you are doing the whole thing here. Let's see. So
And that's okay. I was wondering why does this spit out a U size, but now it makes sense, of course.
yeah, because it's the count off. Yeah. Yeah. So you executed it. Okay. So let's go to your approach. Doesn't matter. Let's go. So from 0 to rows, from 0 to calls. So you're reading from left to right. This is incorrect. This line, I don't know if you can see my selection, line 89.
I can.
That is incorrect.
Where was my... Yeah?
Column is the position in the x direction from left to right. Highest is the height. You're comparing the position to the height.
Okay.
That's not what you need to do. So the approach, what you are trying to do, you are in the right direction to compute part of it. But this is incorrect. Let me write it in a different way. Same code.
Okay.
Same code or very similar code. So one thing I don't like about this approach, okay? I mean, the design is okay, but about the syntax, I'm trying to, Clippy always goes behind me trying to say like, don't do this, do that. This is more like Rust. So I got too used to that. So I can do row in self rows, iter. In rows, no, in map dot iter mat, and that will split directly the rows. And then for cell in row dot iter mat, and I can get the cell. So instead of getting the actual values, I can get here. So let's move the highest here. So now this is just cell.visible. I can just store it. And now this is cell height. So the thing is that if you see a tree that is higher than the highest, then it is visible, and then the highest is the height. So semicolon, semicolon. You always forget the semicolons in the right places. So my code above should be equivalent to the code below, but fixed.
And better readable.
Okay, because I'm not going over the actual numbers, I am going over the actual values. Let's see what this prints. Oh, so this is doing from left to right. This is doing from left to right. So now we can do also right to left. It's not that complicated. It's just like when we do the cells, we reverse the cells. And I should do right to left by reversing the order of iteration. Oh no.
No?
There is a bug. Your highest is 0. And we got the problem here. If this is a U8, so 0 is a valid height. Is a valid height, and you need to count it. So in the shell, we can see that the corner bottom right is not marked as visible, and that is impossible. And I'm looking into the sample, and that is because this is a 0.
Ah, yes, so -1 then?
Yeah, but you cannot put -1 because that's a U8. So let's go quickly and change that into a E8, which goes from -127 to +127. So you can have that. I8. And now we can put -1 and -1. We have the special value. Now render now. That looks okay. That looks correct. Now we need to do top and bottom.
Curious to see that. Because the vector inside vector was giving me difficulties earlier.
Okay. Top to bottom, the problem is that we need to transpose it. And for that we need to use the your approach in the loop, because there is no other way to transpose that. There is no other way to transpose that. So we'll do n call. I'll prefix with n to say that is a number. So I'm not mistaken with the actual value. 0 self calls. Let's copy the same algorithm. And now to make the things exactly the same, let's call it cell. Exactly as above, so it's compatible. That will be self map get mat index. So this is the row. That returns an option, so unwrap it. And now get mat and now is the column. So it's row column always, encol and unwrap it. And that should give me a mutable reference to the place. And now I can apply the same algorithm, exactly the same code again. And that should do, so we are doing columns and then top to bottom. That should do top to bottom. Yes, the top part has been filled. You can see the top part being filled. And doing the bottom part is the same code, just as before, we just do ref. Can I rev it? Do reverse of that? Pretty please. Reverse of a range? Yes. It just needs parentheses.
Ah, cool.
It needs parentheses because if not, it's rows.ref. And no, we want the range to be reversed. So that is needed. And that is the bottom one.
Was that it already?
Yeah, you can see the bottom line is all X, which is marking that we have scanned from the bottom. That's the
nice.
one. Yeah, okay. Is that what you... Okay.
And maybe now I can try again with the actual counting.
Yeah, give it a try. Add the counting here.
Okay, I guess then we rename the count scene trees. Mark unseen. Wait. Mark scene trees. Yes.
Yeah, that sounds better.
Of course, I will have to rename down here too. Mark scene trees. Okay, I am curious if I will be able to do this.
Oh, nice. Look my stream. As you move, my screen follows.
Oh, let me see. I am moving up and down, following guest user. Okay, okay, before I try, how do I follow?
Here, you go and click the participant or right-click follow participant.
Right-click
follow, or just click on the left and it will follow by default.
Click on the left.
Like click.
Okay, I have clicked on the left.
Left click will do following. Right click opens menu, and you have focus, follow,
wait.
and follow. You should be able. No, you don't see on the stream, maybe.
Follow participant. Okay, now I am following. Can you do something? It says following David.
Yeah, I can move.
Okay, that is nice.
Okay, so you can. That's nice. Yes, it is. So now you drive, and I'm looking.
Okay.
And the stream is also looking at you.
Ooh, nervous. Oh no! Hold on. I gotta unfollow first. Unfollow. Implementation for 3. Function mark scene trees. Count scene trees. What do we need here? We need self. Borrowed self, most likely. Yeah, borrowed self.
Yes.
And now I actually know why the usize is returned. I kind of feel like I have to copy and paste the whole thing from mark scene trees and then remove a bunch of stuff. Wait for row if in self.map self.map.itermut. Okay. But I actually only have to copy 2 of those. I only have to copy 2 of those. One that uses your original syntax, and the other that uses my modified syntax. Paste. The ref up here is not needed.
Question, why do you think you need to loop 2 times? Like, you pasted 2 blocks of 2 loops each.
Oh, true, I actually only need one. Right, then let's go with the simpler one. I was thinking wrong. Let mut count equal 0. Count. What are you complaining about now? For row in self.map.iter_mut. But why mismatch type? I give it. Oh, okay, I see my mistake. Yeah, now we can be friends again. Okay. So let put count.
I formatted. I press Ctrl S to actually format the file. Because I cannot see with that mess of brackets in any random place. So I press Ctrl S to format the file.
I see. I think it would have formatted anyway, because for me it does that automatically.
My settings are different as yours. For me, it doesn't format until I do Ctrl S. And for me, it doesn't save until I hit Ctrl S.
I see. So when it does auto-formatting on my end, it doesn't arrive at yours?
Maybe not. I'm not sure.
I'm kind of curious, actually. I will press Enter 3 times now. Now I will... okay. It doesn't do auto-formatting. So for row in self.map.iter_mut can't borrow self.
Yeah, you want the regular iter, not iter_mut, because we are not going to change it.
Let mut highest. Highest is not needed. Iter if cell.height. If cell.visible equals true. Count plus equals 1. I think that's it already. Aside from... yeah, okay, and...
Okay, 1 second. So that is the bracket to open. That is a double equal.
Oh,
okay.
We added at the same time.
Okay, and what is wrong now?
Mismatch types expected use size. Count as use size?
No, it's not a use size. No, it is.
Yeah, I was meaning at the end to type count as use size.
But still... there is still... but okay. You keep doing a mess of the brackets. Okay, and equals...
I'm just used to auto-formatting. I'm just used to clean it up for me.
What I'm saying is that you tend to remove brackets by mistake or not adding them, and then the auto formats what it thinks it is, and then it messes all up because it's not yeah. The equals true is not needed because by default a boolean will evaluate the if.
Okay.
That's the same.
Yeah.
Okay, and that is correct. Let me try something instead. What if we do self map iter and then we want to do for each one, we want to map the contents. I need to practice this because this is very handy and this is good to practice. So
do you want to put everything inside a single line?
Yes, so if we do iterate the inner one, then map if X is visible, actually I don't need to do that. I can do just there is count tells me the amount of filter by X visible, so we count only you only get the visibles, then we count the resulting that returns a usize, and then we have several counts which we sum, and let me guess, is this correct? Yes, it is correct.
Nice.
Is that readable? So
Is that totally readable?
we go to the map, we iterate over the rows. For each row, we iterate every of the cells, like row, comma, column, and filter those that have X visible set. So of those that have X visible set, we count them. Then we have, for each row, we have the number of visibles counted. Then we sum all rows together and we got the usize, which is exactly the same code. And
exactly the same code. So will this be saved to the same assembly?
It should. It depends on how smart is Rust. It should. With optimization set, it should lead to the same code. But as usual, what happens with the compilers is that they have a hard time unraveling all this mess, so those 3-line mess, into this code, because the code that you wrote is what the compiler needs to do in assembly. So it needs to understand a lot of stuff. For this particular, it should be the same. In some instances, it might be not exactly the same. It might be slightly more inefficient, but the difference should be negligible in all cases. They are working very hard for the compiler to do this correctly and very fast. They want this to be one of the primary ways for you to munch through the data.
Nice. Rust is awesome.
It's very good because it allows you to do a lot of abstract stuff that is not costing you almost any cycles. Maybe some cycles, but very, very minimal amount. Very, very minimal amount. Everything costs always something, right? And the differences between C++ and Rust also means that there is different cost associated to different things. There are things in Rust that might have different costs as in C++. So that means that some programs or some abstractions are cheaper in C++, other abstractions are cheaper in Rust. But the difference is...
As long as it's more or less the same, then it's good.
Yeah. I mean, we are talking about very minimal stuff. Very, very minimal. Unless you were, I don't know, creating a huge loop over something very particular, it should not be noticeable. But yeah. So this is the code. Very well. Very well.
Can we try both approaches?
Yes. Let's try. We can do something. Value1. And sorry, I'm going to remove the following because it's making my screen jump. I don't know why. And then we have count. Then we could do here assert equals value1 count, which means that when it reaches this line, at least in debug mode, in the regular mode of compilation, I mean, as long as it's not released, compiled, both should be the same. If not, it will panic at this point. So it will
Also, assert equal only works for debug mode, for debug builds.
It's possible that it gets removed in release. I'm not sure. It depends on languages. Some languages remove that. Panic. Let's see. Oh, so no, it works always. It doesn't say. So maybe this is from Python or something. Yeah, Python was doing something like that. Okay, so it works in both.
That's good.
Python
I
has
wouldn't like it if it only worked in debug.
Yeah, Python has something like removes asserts on release mode. So why do you want to go and print it?
Sure. dm dot.
After the debug, after the if debug, because we want the debug first, and afterwards we want the actual result. If not, it will look strange. We'll have to scroll up in the terminal.
Okay, so afterwards tm dot scene, no, count scene trees. Then copy the print again.
Just print it without debug. So without the if debug. The if debug is for things that you don't want to see on the full input. But the actual answer, the final answer, we do want to see that at all times.
tm doesn't implement tm dot, I guess. Tm dot what?
It gets returned. Okay, the value is returned. You need to store it in a variable. The method returns the value. You are not storing it. That's it.
Oh, so I do this.
Yes. And what I was saying, and this is the good thing of having access to the same program, is that I don't have to make you understand. I can just make the change. So I don't want that inside an if args debug, because this is the actual answer of the problem. When you don't want to run into the bugs, this is what you want to see. This is the actual data you want to see, not the. So the args.debug is to remove the debugging of the whole TM, the whole tree map, because that could be big, a lot of data. You understand what I mean?
Not quite.
Okay, so let me see. Let's execute it, okay?
Okay.
So
21.
21. Let's put
21?
here number of scene trees. Okay, so we see 21. I mean, it's a 5 times 5, so it's 25 minus 1, 2, 3, 4. That looks correct. So now imagine we do this on the big input. Like that. And this is huge. The amount of input that you have here is very big. So
the last line is a bit suspicious to me.
No, that's correct. That is all x. All edges need to be x. If not, that is...
yes, of course. Oh, of course.
Because the first tree is always seen from all 4 sides. So if I remove the debug, now you only see the answer. This is the point of the debug. To be able to hide a lot of extra information that you might not want to see when actually running the program.
That I get.
So that's the reason for the args.debug. So that's why I don't
I
want
think I even used something like that before, but I can't remember the context.
Mm-hmm. Well, we now have the answer. I'll go trust this. Also, the assert didn't fail, which means that both codes are returning the same value for all the options that are being computed. So yeah, that code is being checked. Let's go and try.
Eager to see.
Answer 1932. Submit. That's the right answer.
Oh no, I can see. Browser.
I'll wait.
Nice.
Yeah. Now, continue to part 2. Let's see.
I cannot read part 2 from here.
No. You know what we can do? New file. Problem.md. And now,
Oh yeah, cool.
copy, paste, save, and now we can part 2. We are here. Okay. Content with the amount of tree cover available. The else
It's not here yet. It's not here yet.
is not in your
Oh, hold on.
file in day 8 problem.md.
Okay, I have it now. And I want to follow you.
Yeah. So I'm
follow.
here. Okay. Yes. So content with the amount of tree cover available. The elves just need to know the best spot to build their tree house. Okay. They would like to be able to see a lot of trees. To measure the viewing distance from a given tree, look up, down, left and right from that tree. Stop if you reach an edge or the first tree that is the same height or taller than the tree under consideration. Okay. So it's like the house is built at the top of the tree. So we put the house at one of the trees, and the tree that we put the house is at height 5. The tree house is also at height 5. So now we look down. So we are doing now the reverse. We are seeing how many trees we can see from taller to smaller. As soon... Okay. It's the same height or taller. Okay. Yeah. The elves don't care about distant trees taller than those found by the rules above. The proposed treehouse has large eaves to keep it dry, so we'll be able to see higher than the treehouse anyway. Okay, yes. In the example above, consider the middle 5 in the second row. So we are here. By looking up, the view is not blocked. So this is this one. So it can see a tree of height 3. That's correct. By looking left, it's blocked immediately because we have a tree value 5. So it can see only one tree of height 5. Looking right, view is not blocked. It can see 2 trees. Okay, and looking down is blocked eventually. It can see 2 trees, 3 and 5, right? 3 and then 5. Yes. A tree scenic score is found by multiplying. Whoa. The scenic score is found by multiplying together. It's viewing distance in each of the 4 directions. For example, in this tree, this is 4. Found multiplying 1 times 1 times 2 times 2. So. Okay. So it's the products. So you can see only 1 tree, 2 trees. 2 trees is 2 times 2 times 1 times 1, which the result is 2 times 2 is 4. That will be 4. However, you can do even better. Consider the tree of height 5 in the middle of the 4th row. Here, let's do this ourselves. So 5, it can see 1 and 2 to the top, 2 to the left, 1 to the right. No, 2 to the right, because the 9 is also seen. 2 to the right and 1 to the bottom. So it's 2, 2, 2, 1. 4, 8, score 8. Scenic score is 8. Okay. Which is the ideal spot for the treehouse. Consider each tree on your map. What is the highest scenic score possible for any tree? Hard time following the problem.
As usual, as is tradition. You already have an idea of how to approach this?
I know what needs to be done. I still don't know the code, but my question is, do you understand the problem?
No, I don't get it at all.
Okay, what if I go to the spreadsheet and we go over here?
Okay, go over. Can you do something with your mouse? Because I scrolled away and it says following you, but
Yeah, but
okay, this you meant.
Yeah, to the stream. So let's recolor that. Okay, so what they are saying, okay? So in the example, they first selected as a test this cell. Okay, they say, okay, let's see if we can build the treehouse in this position. Okay.
Is the data that we gathered from the first task completely irrelevant now?
Yes, it's the same data. I mean, you mean the code that we did? Probably not.
Yes. Okay.
Probably not. I mean, follows similar pattern, but I don't think we are going to reuse much code, if any. At least the data structure seems quite good. We can see we need to do something else, but yeah, at least the data is properly parsed. So we start from here, okay? Now the question is, how many trees you can see from this position, okay? And the rules are quite strict and simple. Says, you look only in the 4 directions, only up, down, left, and right. Forget about diagonals or anything in the middle. It's only 4 directions. And count the number of trees in that direction until you hit an edge or you hit a tree that is equal to the tree house or higher. Okay, so you can continue as long as the tree is lower. So if we look towards the right, 1 is less than 5, so we can see this 1. 2 is less than 5, so we can see this 1. Okay, we hit the end. Okay, we hit the end, we stop counting to the right. To the top, 3 is less than 5, and we stop counting. To the bottom, 3 is less than 5, we count it, and we keep going. 5 is not less than 5, so we count it, and we stop. We count that 1, and we stop. So this is the last tree you can see. And to the left, 5 is the last one because it matches the same number. Then you stop. So then how many trees do you see? So in each direction, you have to count for each direction. So one direction, so there will be up is 1, left 1, right is 2, down is 2. The red one also counts. This is the stopper, but it also counts. And then the scenic value is just the up times left, doesn't matter the order. So all of them multiplied. Which is 4. So it's 1 times 1 times 2 times 2, which is 2 times 2, 4.
Scenic value. Okay, I see.
Okay.
Oh, this is convoluted.
And then the task is to find the highest ascenic value possible, which means that you need to try all possible 3 positions.
That
So-
sounds fun.
Yeah. So let's go with the second example they gave. So in the second example, they placed them here. Let's put it this time in blue. Okay, so then up we see 2, and we stop because it's a 5. Okay, to the left we see.
Do we need that? I think I already get it.
Okay. So yeah, we'll just finish it.
Okay.
Bottom is 1, and then the 9 is higher, but we also see it. So then up is 2, left is 2, right is 2, down is 1. Scenic value is 8. So this one is higher than this one. Okay, then 8 should be the better answer for this problem. We'll need to test all possibilities to see what is the maximum and output that number. Okay?
Yeah. So the first thing that comes to my mind is a struct tree that contains an ID for row, an ID for column. And maybe a vector of integers. Oh, and a height value and a vector of integers. That is my guess,
What are you trying to store everything?
basically. Can I make a struct how I imagine it?
Go for it. Let me follow you.
Okay, yeah, and I will unfollow. Right click.
There is. Can you see my stream?
I can see your stream, yes.
There is here a pin. When you're on the code, there is a pin for following and unfollowing, and the speaker.
Okay, I
The
see.
speaker is to focus the participant, so you can use that as well. I found it recently.
Nice. Good, then I will in line 72, 73. Derive clone debug. Not sure if I need any of those, but won't hurt to have them. Size or U8. CU8. U8. And I guess scene. Egg U64.
Okay, yeah. Row and R and C were row and column, right?
Yes.
Okay, row and col are very typical names for that. And the other thing, those are positions in memory, in reality. Because that's a position in memory, is a position in a vector, index of a vector needs to be usize. It will give you a lot of trouble you put U8, because all the indexes in a vector, or every time you try to locate something in memory, it is usize. So if you put U8, it's going to ask you to do as usize every single time. So just store usize, one problem
Okay.
less. 80, we were storing it as E8, so let's do that. A scene is a vec of U64. What is that?
The scenic value.
Okay. Can you give me an example?
1, 2, 2, 1, and then it would be put in a sort of function later on down the line. Dot sum.
Product, no? It's product. It's not a sum. It's the product.
Yes, product.
Okay, just so I follow. Okay. Okay, now how do you want to follow that?
Struct tree map, tree data. Oh wait, let me look again at tree data. Height visible.
Yeah, you don't care about visible right now, just height.
Tree map. Tree map.
I mean, you could put your scenic value inside of tree data and call it a day.
Scenic value. Side of tree data.
Because tree data exists for every combination in the array of row and column.
I mean, yes, I agree. My concern here is that dealing with a row U size and a col U size seems easier to me, seems simpler than dealing with positions in a vector.
Okay, feels the same to me. So, okay, let's leave it at that, and let's see how do you want to follow.
Okay, let's see.
You have part 2 below to do the part 2. Okay, you see that there is a part 2 function.
Yes, but
So-
of course, wait. Where is the main function though? Main function does the parsing, right?
The main function, you don't touch it. Main function doesn't touch. We don't touch it in. You go to the part 1 parsing. The parsing is this part here. You just copy, paste, undo contents, args, like that, and you have the parsing done.
Okay, so let's move TM. TM is tree map, but I don't think we will actually work with a tree map here. And why did I look at the tree map?
I mean, the tree map has at least has the data already parsed. So from there you can convert it to something else. But that is working with that is probably easier than parse it again.
Okay, so I should get the trees out of tree map. You are saying?
Yeah. Always build up. Just refactoring for the sake of refactoring is the point. And also, usually we would put a function. So ideally, we'll be coding this right. We'll be making this a function. So instead of copying it 2 times, right? We'll do something like, as we were saying, parse. So like, let me 1 second. I'll write this so you can see.
Yes, that would be helpful.
Parse data, which is contents string, and this returns a tree map. And then this basically contains all this code. The debug No. The debug is up to the caller to do the debug. And then that returns TM. And then for part 1, we just do elmo3map, and this is parse data contents. Okay. And now in here, the same, parse data contents.
Okay, very cool.
Okay.
Args debug.
I'll move this above. Just put some organization, part 1 and part 2 together, and the parse is above. Okay. Yeah, the debug is the debug. You can ignore the debug, or you can remove it if you don't like it, but that is usually...
No, I want it.
Yeah.
I always like to print out as much as possible.
You need to pass P2 instead of P1.
P2, okay. Yeah. And D, right?
Yes.
Does S mean?
S, sample data. Which will means
that... nice.
It loads the sample input if you pass that -S.
Wait a minute. That seems wrong. I guess because I didn't do mark scene trees here. Yes,
but we don't want that. In this, we don't care about that function anymore here, so we are not carrying the visible here. I mean, in part 1 you leave it, but in part 2 we don't need it. So it will be visible false. In
part 2 we don't. I think just for my own ability to follow what is happening, I'll put it. I'll put it here, but with the ability to comment it out later.
Yeah, good.
Myself. That is something that I am more comfortable with. So
if you like it, you like it. I mean, you can just leave it and that's it. I mean, I have no problem with it. So just leave it normally and that's it.
Okay.
Yeah, I mean, there's no problem.
TM. What is TM? TM is println TM.
By the way, I never asked, does Rust Analyzer work on your side?
I think it ended up working. No, wait. So it seems it doesn't work because letmod TM is not underscored.
Oh crap, okay. So
and I don't have any of the auto formatters, so looks like the entire time I have been working without Rust Analyzer, but it does give me warnings. It does give me proper warnings.
Oh, okay, that's something, okay. Okay, so it's giving you some help. Okay.
Maybe the warnings are passed on to me from your end?
I don't know. Maybe.
Server is stopped, click to start. Nope, Rust Analyzer is disabled here. But okay. I do have the show code actions. And it does autocomplete. It actually, like when I use something like parse data, it would do an autocomplete for me. So okay. It's odd. I don't know what is happening now.
So you have some help, but not much. Okay.
TM is a map. TM.map.
Yes.
And now I'll do another number. That is wrong. What am I missing? Vector, tree data.
Tree data maybe is not debug. Can you derive debug on tree data?
Yes. Tree data default debug. Yes, now it only gives a warning. Height 2, visible true. Okay, in that case, I think I will need the loops from mark scene trees again, or from count scene trees? Let's see, I want to try with the function from count scene trees. For row in cell, gonna go with my code because I understand it easier. Paste. Oh, I don't need a semicolon there? Looks like I don't.
No.
tm.map iter. If cell visible for cell in row.iter, if cell visible, that actually the if condition isn't needed. But I need to create, before I do anything here, I need to make a vector from trees. So let trees equal oh, it's complaining?
Yes, you need a type if you haven't pushed, so that will be 3. Sorry, a vec of 3.
And needs to be mutable. For cell in row.iter.
And I think what you want here is enumerate and enumerate. Just so you have here n row, the row number, and n col to get the actual row and column value number.
Okay. Now I'm wondering though, 3. Let's see, 3 is a struct. 3 is a struct, 3 is a struct. I am rethinking things in my head. I think we will need a hash map.
Why?
To point us. Yeah, to point us to the tree that we need.
By which key? What is the key to look up? Row and col?
Yes, row and col.
You don't need a hash map for that. So follow me for a second.
Okay, I'm following you. Hold on. I am pinning. Okay, following David.
Okay. So get tree self returns a reference to tree data is basically self map. You want row usize comma col usize as inputs. So that is first is the row. You can do .get, for example. You want to be more row unwrap get call unwrap. That will give a reference. Say that you want to modify it. Then you do a get mut tree that will need to get mutable reference to self that returns a mutable reference, and it's just a get mut and get mut. Here is your hash map. There is no need for hash map. So hash maps are for things that are not like 1, 2, 3, 4, 5, 6 in order, that are all set. Hash maps are when you have labels in letters and things like that. Or if they are numbers, they are very sparse numbers, like 200, 515, 3 millions, and they have very random numbers that you cannot put that into an array. This is already in an array, and you want to access by the array numbers. Just that the syntax for you is a bit unwielding. It's complex for you still to get. But you can use those if you want. Those work. You can just do get tree and get mute tree, and they will work. So, for example, you're still following me, right?
Mm-hmm.
So let's say, for example, that we are doing row in 0 to tm rows, like the other code, okay? For call in 0 tm calls, you could do cell as the current square, being tm get 3 row comma call, and that will give you the current cell when you have height. For example, say that you want to mutate it, you can do let get mute 3 and then cell be mutable, and then you can mutate the height or whatever. That works for you, right? You can do tm get 3 or tm get mute 3, and you can use that.
A lot of information, trying to process it to the best of my abilities.
Okay. I was I tend to go very fast, sorry. Okay, let me know when you finish, because I had an extra thing to tell you.
I mean, you can go on. It's just that I probably am not going to understand this immediately, but I think I am going to take something away from this.
Okay, so this cell here is the same as this cell here. This cell contains is pointing to the same row and column. It's just that this is n row and col. I mean, you know the problem. Naming variables is confusing. It's like,
yes,
this is row list. This is row list, just to make it more straightforward. So the cell is a particular tree on row comma col in both codes. They give you the same. Of course, this is good if you want just to iterate them all, but if you want to access a random one, because you want to do later on to access the vertical axis or the horizontal axis, then get3 will give you this random access that you are looking for, right? Okay, seems that you are following so far.
I'm trying to.
Okay. Yeah, so I would say don't worry too much on the get3 implementation or get mute3. That just use it. That's it. You cannot
row and call. So. Cell height. In line 220. Cell height, but what is cell now?
So you are iterating through all of them. So for each n row and n col, so for each row and column, cell represents the current one. So cell is the square at that row and column, or what you call a tree. It's a single tree. It's a tree positioned at the row and column. Cell. I'm using the word cell because the from spreadsheets, you have spreadsheets go in rows, columns, and then each square in a spreadsheet is a cell.
Yes, that I'm aware of.
So that's why I'm calling them cells. So a cell is basically a tree here, single tree.
Hash. Okay, hold on. I still So from what you just did, how do we get from there into the position of vec3?
Do you care about the position in vec3?
Yes.
Currently is empty.
Like, yeah, but after we fill the tree vector with all the structs.
I mean, you can always do trees. You can always do trees I, and I will give you the tree, or get I, or get 0, and that unwrap, that gives you the tree.
Trees get 0. Get
But I'm not sure what you want to do because currently is empty. You need to push to the vector to
but
fill
you
it first.
already have an idea of what structs it will be filled with, right?
I mean, I know what the code tells me. The code tells me that it contains 3 structs. I can do what I think you want to do. I can try myself what you want to do, and you you tell me.
Okay.
Let's use this code. Maybe it looks simpler to understand than the bottom code. So it seems that you want to do the following thing: 3 equals 3. Fill me the struct fields. These, let's just name it row and call, so I can do this directly. And then
I like that so much.
Yes, and then this is cell.height, and this initially will be an empty vector, and now you do trees.push 3. Now,
Yes.
after that, what I think you want to do is for 3 in trees get mat. No, get mat, no, sorry, iter mat. Because you want to change it as you go. Then here you will do something like 3 compute scenic value, and that to store to store the scene part. Then total scenic value, then iterate again. So just stop me if you see that you're following me right now, no? So you're seeing me scrolling. We have 3 implement 3 just to make some sorry, my keyboard. Function compute scenic value, that is mod self, because we are going to store self scene equals vector, and do some magic to compute the borders and store into self scene.
The 4 Ds?
Yes, top down.
Okay.
Into this. How we don't care yet. Total scenic value. Let's go up again. Total scenic value. This is just percent self, and this returns U64, and this is easy peasy. This is basically self scene iter. Tell me you have a product. You have a product. You are the best.
I agree.
You are the best. I don't need to do this. So I mean, if we want to do this, will be let total equals 1, you need to initialize with 1 because it's the identity value for products. So when you sum, the identity value is 0 because adding 0 doesn't change the value. For products, for multiplication is 1 because you multiply it by 1 and doesn't change. So you want to initialize with the identity.
True. True.
The identity for product multiplication. For self-sin, sorry. For the score in self-sin, I can put a percent, to avoid putting here .iter. Oh, you don't. It's the return value. It's the return value. We return total. Right. And then total times equals score, and that gives you with mutable, of course, and that gives you the equivalent code, right?
Yes, you understand my thinking correctly, and I think that compute scenic value needs to end up making use of the quote-unquote hash map.
Yes, you need to access the whole thing. To access the whole thing, you're only going to read, right? Because you're only going to read, you need the tree map, which is the whole thing, is your hash map, contains the whole thing. Reference to tree map. And then from here, when you want to do, for example, the above, is tm get.
Oh, so I'm not going to read the other values in the tree vector. I'm not going to read them at all because we already have them in the tree map.
Yes.
Okay, so that is different from my initial thinking, but definitely the better approach.
So you do something like that, it gives you the one above, you do height, and that outputs the egg that is above, like on top. Yeah, above. Okay, so that's one example. One thing that I'm seeing coming,
out of range.
Yeah, because it's gonna happen. It's gonna happen. Wait, we can do this better than that. Instead of expect.
Unwrap or?
Unwrap or default unwrap else. No. Unwrap or else will default, and this expects a constant string. I want to put the row in here, the row value, but I cannot because this is an ampersand string. Do you have? Let me have a quick search. Actually, what they had on the beginning, I like. So they are just putting an ampersand format. Okay, not the best, not the most. Let's put it in here. Close parenthesis. This is row. Dot. I think to make a full range. Yes. Now you will see when it errors out. You will see which value was row.
That is awesome.
And I can also put both, because then you will know what you are accessing exactly. Then you will know what you are accessing, because it's gonna happen. You are going to see out of bounds access in these kind of things by mistake. Yes, we do hear that. That's the product. One thing more. Okay, what is the error? Trimap is missing. Yes, trimap is basically a %tm. That is done. Next thing, and I'll leave you to the part of the code. So this returns the total arsenic value. We want to get the we want to extract the maximum from this. So basically you want to do trees, iter, map with this. So x dot that. And then you want to do the max, yes, max scenic equals that, and bring the len something like that, max scenic. So even if I was very fast, this is yes, because this is an option, and I want to leave let's write it here. This is an option U64. In case that we don't return anything, an empty array, an empty list by some reason, it's good to have this option return none. So your code will execute and you'll say max scenic value none, or sum and a number. At least is one thing that it cannot explode, because so many things are going to explode in the code above.
Wait a minute. Sum none. So sum none options is eternally an enum, right?
Yes. This is. Are you following me or looking in stream? Maybe looking.
I am following. I can see option.rs.
Yeah, this is the source code inside Rust, the compiler. So this is how it's defined. So option is just an enum that has none or sum. That is what it is.
Oh, and wait, so T is a stand-in for type?
Yes, for any type. Option T means any type. T is any type. You make an option out of anything that you want.
I think that's an implementation of the Rust enum that I'm completely unfamiliar with.
Those are called generics. So if I move this here, let me just remove all the garbage that makes this hard to read.
That's the difficulties of not having a garbage collector.
Okay, that's it. Okay, so this enum is an option 1 for any type T. So the brackets is for specifying the types that you want. And that means that if you have option 1 U64, okay, this means that this how is to say, imagine this. Imagine this. You have two different options, okay, and one is U64, the other one is bool, okay, to make things simpler. So this one is U64, this one is bool. Those two, in the end, you do understand how they work, right?
Yes.
Okay, here is the problem. I need to keep creating different types for every possible combination. every single time and naming them differently, which is very cumbersome and very hard to support. Right? That's very hard to support. What if the compiler could do this for me? So turns out that when you do this option and then between the brackets, the angle brackets, U64, this is creating a none inside and some U64 inside, because T is the placeholder. There's a placeholder for the type, and as I put the U64 on the name, it goes into here because it's in the sum variant. So where it sees the T, is replacing it with the type, and that makes the advantage that if I make a struct, my struct that contains whatever I want to, doesn't matter, whatever I want to contain, I can make an option from my struct, and this will incorporate my type into the option enum that the compiler or the Rust library has no awareness about.
The T, the placeholder T, does that have to be a T or can it be anything else?
Any letter. It can be even names. Can be
Can
X.
none and some also be anything?
You can put also here X if you want to have the none with the same type as a field. If you want, you can have it multiple times in different places, or X, X. Then it will have a tuple of 2 times the same type. You can also make X, Y, and then that uses 2 types, and then Y here and Y here, for example. That's also possible. And then you put to use this one, you will do U64, bool, and then the first one becomes X, the second one becomes Y, and then it does the none and the sum in the same way, replacing the Y with the bool and the X with the U64.
So I thought that I finally understood the Rust enums by now, but turns out I'm not near understanding this.
Oh wait, this is not actually enums. This is called generics.
Huh?
Generics is when you have type something bracket X, Y, Z. Those are generics. This thing are generics. The fact that you can create multiple types from a single type. It works with structs as well. With a struct, I can have a struct, my struct X, and I can have row usize, call usize value X. And then you can create variants of my struct where the value is a string, where the value is a date, where the value is a boolean. You can create as many variants as you want. Those are generics. It's not particular of enum.
Are generics a thing in C++ as well?
Yes. C++ was one of the first ones on having that. In C++, it's called templates.
I see.
And it does the same thing. It's just that in C++, it might be a bit more powerful and a bit more error prone, because it does more like replacing the text or something like that, and sometimes it can mess up. But the basic idea is the same thing. It has different names because generics means that it's a bit more structured, a bit more limited, so it doesn't explode. So the compiler understands better. A generic is better understood by the compiler. Compiler will give you better errors. Where C++, because it does this replace magic, if you have an error because of a template, it will spit out a very weird error because the compiler doesn't understand what it is doing. But it's the same. They look very similar in C++. You will see very similar syntax. And this is very powerful. You have also
I imagine.
You have also generics in the result. if you have a result, let me call it here let y result definition. Here it is. So the result is an enum of type t, e. T defines the type of the OK, and E defines the type of the error. So it's an enum of OK or error, but you can define yourself what do you want the OK type to be and what do you want the error type to be, and it can be anything at all.
I use this in my guessing game.
Yeah, of course. This is a very common thing. The result, you need to use the result. We are using it under the hood here as well. So if we go back on the debug thingy, here, this result, this is the regular result. Is just that defines that the OK value is empty and the error value is error. Is the error type. But this is a result enum. So here you need to return OK or error. It is all over the place in the Rust standard library. In Rust, you are forced to use options and enums. There is no way to avoid options and enums in Rust.
I mean, it's good. I like it.
Yeah, unless you don't use anything from the standard library or core library and you define your own enums and your own stuff. There is people that do that. I will not be the first one to suggest that. So okay, I'm going to...
Oh wait, so the options enum is actually only part of the standard library?
I think it's part of the core library. There is a core library and a standard library. I think it's part of the core library. I think.
Huh.
But there is people... So the difference between a core and the standard is that the core library is a subset of the standard. The core library is a library that you can use in embedded without an operating system. So if you have to write a program such that it has to run without an operating system, for example, because it is an operating system in itself, like you are writing Linux, or because you are writing a program for a device which doesn't have an operating system, like an Arduino, then you cannot use STD, and you are only allowed to use core. And the core has...
So that's what's done in the Linux kernel?
In the Linux kernel, probably, I'm not sure they are able to use the standard library. Maybe they are because they are writing drivers. And maybe at the driver level, you can access the operating system. I'm not that sure. I'm not that put into... But if you want to write the whole Linux, the whole operating system, the kernel into Rust, you want to make a Rust kernel, the core part of the kernel cannot use the standard library. Because the standard library, so for example, what is part of the standard library? The vector. Vector is part of the standard library because it has dynamic memory allocation. That does, you remember the malloc? You remember cmalloc? That calls the OS. Because it calls the OS, if you don't have an operating system, you cannot call malloc. You need to implement malloc yourself in a kernel. So that means that your program cannot use the standard library because the standard library calls malloc internally to do vec allocation because it has dynamic sizes. So you have the limitation that you need to know what is the size of everything beforehand. You cannot do dynamic allocation. Even a string, even just the string with the uppercase. So a string with uppercase is std because it has dynamic memory allocation. So that is only with an operating system. So yeah, our program is that we...
Can you repeat that? That I want to understand this point.
So strings have dynamic memory allocation. Like the amount of space that a string takes is dynamically allocated. Are we okay to that point?
The borrowed string?
The borrowed string is not, because the borrowed string is just a pointer. So str is just a pointer to a string. So it's similar to see on Signet char star. It's just a pointer to memory.
Okay, never mind. I don't need to understand this today.
Yeah, basically it means that if the string is already memory, if we don't care how the string is held in memory, you can have an $str because it's just a pointer to memory. That's perfectly possible. This is just a 64-bit integer pointing to the point in memory. In order to have a string in memory, if you put static var equals my text. Does it? What was the problem here?
Static.
Yeah. Yeah, this what happens here is that this text is being copied inside the binary. The binary contains this string. When the binary runs, the whole binary is put into memory. And because it's in memory, the binary, therefore this string is also in memory. If you know where this is stored inside the binary, you have the pointer. And that's it.
Static are mutable constants, right?
Actually, no. Static, by default, they are not mutable. You can make them mutable, but you need unsafe to change them. Constants are not stored in fact, I think this doesn't work. So you cannot make a const var string because what const does is replaces no, wait. I mean that works. What this does is that whenever it says it is encode var2, it replaces with this. Const basically replaces the occurrences in the source code, where where static actually stores the data in memory, like in the binary, and then you can reference it afterwards. But my example also works with any function. Any function test that you do let var equals my text. What's your problem now? You want the type? Is that the problem? Because I'm shadowing statics. Okay, var 3. Okay, so with this happens exactly the same. For this variable to be there, that text needs to be inside the binary, and then you can take the reference into the binary memory and get the text from there. This is a bit tying from my presentation about how memory works in programs internally.
Yep.
So this is more or less the idea. So the constants, the things that you write in the program. So put in another way that might make more sense. If I put here all books in text from Asimov, like I put all the text in here, the file size might increase by several megabytes just by having the variable, because it's copying all the text inside the binary. And then you can just get the string from the binary just by having the pointer, the address. You remember in C that this was the memory address, the ampersand.
Yes.
So basically saying like, what is the memory address of this? Which means like you compile it and you put it wherever you want, but wherever you place it, I want the memory address here in this variable. And then from there I can use it. From there I can use it as a regular string, but I cannot change it because it's stored in read-only memory, because it comes from the binary. That cannot be changed. You can create a new string in memory as long as you're using std. It's the standard library that you have malloc to allocate new memory. But in core library, with the core library, that will be possible, but it's harder. It is harder. And that will be a topic that is advanced even for me, how to do that. It should be possible to allocate memory for a string and change it, but it's not
Doesn't
easy.
seem like a particularly worthwhile investment of time to me.
No. Bottom line is that there is the core, and inside there is std, which contains core already, and we want always to use the std because there is something called no std to remove std to do core only. We don't want to do that ever. You want to use std, you want to use all the bells and whistles. Because
I agree.
Why not? This is pointless.
I was bothering in C++ with the fact that so many stuff had by default std in front of it. And I was like, okay, I don't care. As far as I'm concerned, the standard library and the things that are more fundamental are the same. I don't need a distinction between them.
Yeah, the problem with C++ is that what they call the standard library came after the language. That's the problem.
I see.
It came after the language, and this probably they are being standardized at the same time as a single unit, but they are two complete different units. The compiler and language is one thing, and the standard library is a completely different thing. It's like you can make a program without the standard library, because standard library is not really standard. It's basically, they call it the standard library because it's like, okay, this is what we want C++ to be. It's like what they promote. It's not like in Rust that by default you get a standard library. In C, you don't get any library, zero. In C, if you don't have any library, you cannot even print to the console. The only thing you can do is do math and return an error code. That's all you can do. You need libraries on top of that to print to the console, to read files, libraries for everything.
I see.
C++ and C is libraries for everything.
I mean, in practice, it's the same.
Yes, in practice it's the same.
Like, as far as I'm concerned.
Yes, the main difference is that in Rust, if we go to the top of our file, you will see that I have here basically only clap and a few things from the standard library additional, but aside of that, all the generics are here. You don't need this to be very big. But in C++, you will need like IOStream.
Oh, yes, that is so annoying.
For printing, you will need strings for strings. You will need IO something for files.
I can look up how many IO streams I have for my porting of Advent of Code Day 6.
Yeah, so and it keeps growing. Like having 10 is not rare in C++. It is not rare. So yeah.
I'm gonna share in your chat on Matrix. How many I have on the Rust equivalent? None.
Yeah, 7 here. I can't.
Oh, no, I do actually have to use std collections hash map, use terminal. Don't I have something for derived debug?
No, derived
You
debug.
do?
Oh, no. This is not for derived debug. This is the trait debug. That's a different thing. This is to customize how the debug looks and how the display looks.
Okay.
And this one is not needed. Sometimes, because I'm only using them once, I will say I don't want the use, and I will put the std : fmt : debug, because it's just one single use. But I mean, it looks good. Anyway, maybe we should go back to the task. I will remove this thing from here. That's not needed anymore.
I will be back in 3 minutes.
Okay.
I'm back. Max Scenic. We have 2. We have 2 warnings. Why do we have 2 warnings? Do we need a closing bracket? Okay, what do you do now, friendo?
Yeah, I'm back too.
Welcome. Oh no, we have a panic. Attempt to subtract with overflow.
Oh, I didn't count with that. That's the -1 I did before. Let's do +1.
Huh. Above height, below height. Okay.
Because row 0 -1 is negative, and yeah, and now we have out of range. This is 5-0.
So can you explain to me the... Also, it seems I'm not following you anymore. I mean, I am following, but the screen is not adjusting. Let me unfollow and follow again. Okay, now are you at line 84?
Yes.
Okay.
So yeah, I mean, the thing is that I was counting for the one below, and yeah, that one doesn't exist. We can do a different thing here on the get tree. You're following me still, right?
Yes.
What if, because for this kind of algorithm that we are going just to look up and down and so on, we can also do, this one we're not using, just underscore it. For now, if you need to use it, just remove the underscore, okay?
Yes.
If you need a mutable. Okay, so let's say with this returns an option of tree data, which returns none if there is nothing. So we can do question mark.
Oh, is it so basically when it starts with an ampersand, the type is always a point to memory?
Yes.
Okay. For both C++ and Rust?
Yes.
Okay, good.
In Rust is more a borrow unless if you're using unsafe, yes, it's always a point of memory. It is in safe Rust. I'm not sure if 100% it will be. You can most of the times, yes.
I mean, isn't borrow like, I don't know what is internally the difference between borrow and pointing to?
I'm not sure that the compiler, if it is forced to actually pass the memory address. So what I'm saying is, like, in C++, you are 100% sure that that is a memory address. Here, you can think about that, but I'm thinking that the compiler is free to do more stuff, as long as it works. So you can think about the memory address of tree data, which has only read-only access, if that's simpler to you. So far, I think that works always. What this returns? Get returns an option. Like that. Yeah.
Huh?
Yeah, so this will return none. Get tree option will return none. So you can do below if let some cell.
Is it normal to be hungry after coding streams?
Yes, possible. Yes. When you use your brain a lot, it consumes a lot of sugar, so it's possible that it makes you hungry. So yes. Okay, so this variant with the option returns an option. Okay.
Okay.
Which you can unwrap this way using an if let sum or a match. Okay, but if we don't want to care about the none, we can just do that. Then the contents, if it is sum, so this says that if you can put the below this variable into a sum something, so it's like a match with only one variant, then cell contains the contents of the sum. Okay, if you do the else, it will be the none part. But yeah, in this way you can quickly extract something if it exists. If that makes sense. I don't know, you have two options, you can choose whatever you like more, I don't know. This will not panic.
Max unique value 1. That ain't correct though.
Of course it's not, because this code is totally unfinished. Finished. It's not even started. Here I was only demonstrating how to access some random row and column, giving the positions from the tree map. Now is our work, or your work if you want, to actually do the magic code here.
I would like to, but I'm afraid my understanding of this is not good enough yet. So your point of this was to make something that's simpler than a hash map, right?
My point on this is that I don't want to use a hash map for something that I don't need to. Because if you make a hash map here, you will spend a few hours making the hash map.
A few hours?
Yeah, maybe 1 or 2 to convert everything into a hash map.
For you.
Sense. And then in the end, you will end with an access pattern like this, which will give you the same problems. Because a hash map will give you a get. So a hash map will give you something like a get, and then you have to put here the tuple, which will be between parentheses self row comma self call ampersand or something like that, and from there you will
I think that is a good thing that you are doing. Can you write in the code that I would have written with a hash map and the code that I need to write instead?
For which part? I mean, with the hash map, you will have to first build the hash map. You will have to go...
the code... So you just wrote the syntax that I would have used if I had built a hash map. Now I would like to see the code that I need to use instead, if I want the same result.
This line, this is the example. So this is for the same one. So let...
Okay.
My cell is this one.
Good. Can you print my cell?
Yes. Here. Actually, yes.
Is the debug macro the same as println with the debug thingy?
Yes, there is a small difference. There is a small difference in the format. The bug is println. It puts the variable name, and it puts here the file and so. And in here, the format is, instead of this one, is this one, which is kind of the bug. There is a difference in the formatter.
Debug.
Yeah, that it's a verbose debug.
Oh, so, verbose debug, I see.
So this one is terse, and this one is verbose. I don't like it. I prefer the one from the println, but you know what? That for the purpose of doing at the back that I'm going to remove later, I'm fine with a format that I don't like 100% because it's 4 letters and I can write it quickly and remove it quickly, and it puts me the file name, the file line, the line in the file, variable, and everything. And then you can do several variables, comma A, B, C, D, and it does all the things. I don't like the format that much, but it is convenient. It is the hell convenient. So yeah, let me print. So yeah. So the difference that the debug format, the regular one, the terse one, tries to put things more into one single line. Especially arrays. Structs are more or less the same. But for arrays, they are more to the right, where in the back they go to the new line, each item. That is the difference. You can see in the console now that you have the 3 data. We can print also, if you want, self row self call. And now it does for 3 and the data that you're accessing right now.
Yes. That is good. That is extremely good. Three, 1. Yes. Can I get the height out of this?
It's in line 91.
Line 91. Let below height, cell height, some cell below. Okay, then println below height. Oh, doesn't like it?
It does. You miss always the semicolon, but yes, it does.
I guess that's it's not indicated as a variable on my end, so Rust Analyzer doesn't do the proper job. But
you can see that it's the same as in the debug output that we were seeing as the height.
Yeah, but yes, I see it. Okay. If let some cell below. If let some. I'm confused about the option being required. That is sort of distracting for me now.
If you are accessing the same thing, if you know that you're not accessing out of bounds, you can remove the underscore option, and then it will unwrap it for you, and it removes the cell. So the underscore option is because instead of panicking if it goes out of bounds, it returns none, and you can process the none as the cell that I'm asking does not exist. If you don't need that, just remove it. You can always call it later if you need it. Do you want me to do the code with the option to see the difference?
Yes.
Okay. Hang on for a second. Let's copy paste. So basically, you remove the option, then you don't need to do the let some cell, and this is basically below dot echt. Yeah. And that is the same code. The difference is that the second one, if you access one that is okay. cannot find below. Ah, double L. Okay. Yeah, same code.
Okay. Let's below. Ah.
Yeah.
Okay. Can you?
Yeah, tell me. I think that the name might be.
Can you summarize line 95 and line 97 into a single file? Into a single line, I mean. Dot height.
And you will see in the console directly 3 height at cell. You see the debug creates all the variables already for me. I don't need to be printing anything. So that's the thing. You do whatever you like to do. Just tend to use those debug. If I'm going to delete it later, I will use debug. If I'm going to put kind of a debug that is going to stay, I will put a println.
I think I'm gonna play around with debug a lot in the future.
Yeah, for now, use whatever you like. Yeah, whatever you feel. I mean, it's just that it's there, it's useful, it's handy.
Struct tree. But wait. Self.row, self.call, self.row. And here we get the height. So, okay. Okay, implementation tree. Compute scenic value. No. For now, we only get the height. No, we don't actually need the height ever in the struct.
I mean, you can obtain it that way if you want, but it is stored. So if
we don't need it though, right?
If you wait a second, okay. If you output self height, it will give you the same value because I stored it. I stored the same value.
Self.height.
So
but wait, where did you store it?
Oh yeah, follow me for a second.
Following?
So in here, when I create, now that I'm creating in the same pass, I just stored it already because it was handy. It was handy, so it was readily available to me. So I said, why not? And you placed it in the struct, like, yeah, I can feel it. I can feel it.
And get three. You. So that's your hash map.
Yeah, kind of.
Nice. Then I'm confused though about. Yes. Wait.
Where we were.
Compute scenic value. Okay.
Yeah.
Compute scenic value. We don't. Wait. Let tree height at cell. Compute scenic value.
Do you want what we need to do there, or do you want a description? Can I add a description of what needs to be done?
I'm like compute scenic value. Do we let tree height at cell dot height self dot height self scene back. We don't. Okay, we can comment out line 95 and 96, yes. Right?
Yes, comment that out. They are useful for you. I'm going to remove the other code that is not useful. It's going to be noise. I'm going to add a description. So we are considering to put the tree house in self row self call at self height. We want to compute the scenic score value, scenic value for treehouse in this position. That's what we want to do. Like
Good.
in the same wording as the problem.
Then I'm gonna comment this out again. We do get the tree map, right? We do get
Yes.
the tree map.
TM is being passed as tree map in the and you can access any cell, any particular tree.
For now, what I want to access is rows and calls. So here tm dot rows, tm dot calls.
Yeah. Execute it and let's see. At the end,
Always
you can see.
5-5. Always 5-5. Okay, and now I want to try with sample, I guess, input E.
No. Just remove the flag. That's it. 99.
Oh, it died on my end, kinda.
Oh, it's too long for. So maybe sending the output to your side. So the output maybe was too long.
Are we still synchronized?
I'm seeing you moving.
Okay, that's good. Okay,
Yeah.
then
I see the console moving as well. Let me
you
try.
see the console moving, but it hanged. Can I?
Oops.
Okay, I want to kill the console or restart it. How do I restart the console?
Wait, I'll dump the console and create a new one.
Okay, thank you. Thanks. Nice.
Now is in read only. Now read write. Now okay, you should be able to see this output.
Yes, and I can do stuff. Nice. Good. So, what is happening now? Suddenly can't scroll anymore. I'm gonna unfollow. Okay, compute scenic value. Mut self, and self is 3. So this will be tricky. We need 4 loops again.
Yes, we do. Yeah.
We need 4 loops again. Are you following me? Yes.
Yes, I am.
How much from that do you think?
Nothing. I will.
Nothing.
I will not use that.
Okay, got it. Can you share your spreadsheet again, or maybe send me a screenshot of your spreadsheet on Matrix?
I'll put in the chat room.
Cool.
Also,
Stream connect. Is your stream a bit delayed on my end?
yes, my encoding is a bit delayed always.
Because of restream?
No, because of the encoding options. My encoding options that I'm using, they save a lot of bandwidth, but they are not good on latency.
I see.
Yeah, let's do that. Copy link. I'll share that privately. So if you want to access the spreadsheet, you can at least follow the link if you want, and you can see the spreadsheet.
Good, gonna try. The image may be enough. Yeah, it's probably enough. So, We already have all critical data that we need. Fuck, this will be complicated.
Can I try?
Of course.
So, let mut row equals self row.
Does it need to be mutable?
Yes, I'm going to use my cursor trick, variable that changes over time, so I can go around. So, I'll change this afterwards because I'm not sure in which place I'm going to end. Let tree sum tree equals get tree as this, but we want to use this row and the same column, and we want to use the option variant, and you don't like me for some reason.
You missed the underscore, I think.
No.
Or not?
Parenthesis.
I
So,
see.
yeah. So this is a while let.
Get mut3 had the underscore, right?
No. It's not mutable. We are not going to change the other one. We are just going to read it.
No, but you had a get mut, and that had the underscore.
No. I had the parenthesis outside. I had parenthesis here.
No. I mean, in the 3 implementations, one of the options is to get mut3, if I remember correctly.
I do have it. Yes, but
that is underscored. That's where my confusion came from.
Yes, that one is underscored because we don't need it, or at least not right now. I don't think we need it. So we start from, let's say we're going up. So going up. And tree height. Let me comment this for now, so we have less noise. And now row minus equal 1. The problem is that this will, if row is 0, we'll need to break, because, yeah, it's usize, that's the problem. But
This 0. Wait. But there is.
Yes, because of this one. I'm starting to give 2 fucks about this.
Size.
Okay, follow me along for a second.
Oh, yes.
Follow me along for a second, because this is going to be if row less than 0 or call less than 0, return none. As usize. Now we can do that, and now in here,
Nice.
self call as is size. No, this is just call. Okay. Still subtracted overflow. 1 sec. this one is first convert to signed, then subtract. Yes. Yes. Let's use the sample data. So it should do. Let's do here debug self row to try to understand what it's doing. Exactly. So we have row 4, column 4, and then it does row 3, row 2, row 1, row 0, and stops because it's out of bounds.
Because it's out of.
So the next one will be row -1. So it exits.
While let sum 3. Row 0. Wait, row 0. So row 0 is actually row 1.
Yeah, of course.
Okay.
Row 0 is the first row. Yes. So that goes up, and we can scan the height of the trees going up from the position of the tree house. Okay. So we want to go down. So
good that you are adding comments. That is still something that doesn't get into my muscle memory.
let's put going down. So the code is exactly the same. The difference is that we are doing +1, +1, and it's the same. So now okay, we can see.
Oh, wait. Can you show me the code that returns none again?
This code here, line 143.
Yes, if row.
Oh yeah. So the trickery is the question mark and the return value here. So the first part, the if is clear. So the thing is that
Yes.
I need to convert the I size into a U size, right? So I need to discard the negatives. Okay, I cannot handle the negatives with the line 147. The line 147 needs already positives. So for the negatives, I already return none. I cannot handle it below. So far, so good?
So far, so good. But I'm not getting. You did up and down now.
Yeah, this function is a bit magic because it can handle the 4 directions already. This code, because the .get, when you do .get, this get returns an option. Let me.
But how does it know when to quit at the maximum number?
Exactly. So when we access with a number that is too high, the get returns none. This get returns an option. So when the number does not exist in the vector because it's too high, get will return none.
Oh.
And the none. So the last one, the last .get, we are using that none to return it directly without the semicolon. We are returning that none straight away, which is for the column. For the row is a bit more complicated because it's interwindlet here is in the middle. So that's why we have the question mark. The question mark is a special syntax in Rust that is saying if what is on the left is already an error value and none is considered an error value, then break the code flow and return the error value already. So this is unwinding or expanding into something like let row equals let's put it here. This match row and then some row we do something none, and then for some we do this is the same code. Both things are the same. The question mark is doing some sort of match automatically because it knows that none is an error code, and then when it takes the error code, it propagates the none straight away outside of the function.
That is amazing. Can the question mark also be used for custom error codes?
Yes.
Nice.
It works so far. I noticed it works with option and result, but I have seen other people using it with other stuff that are not the standard libraries, options and default and result. Are you still following my user, right?
Yes, I'm following the entire time.
When I do go to definition here, I noticed something here. Lang non-stable feature. No, it's not here. It's not here. They, I don't know how it's done. There is. Maybe it's a trait.
Is in your matrix, right?
Yeah, maybe. But I mean, it doesn't matter. I bet there is a trait or something you can implement to your custom type to tell Rust that this variant of the enum is an error code. Something you can tell the compiler to treat your custom type as an error code, that to have an error variant. I'm almost sure that there is that is a possibility. I'm not sure right now how that's done because not that I need it.
Yeah, we don't need to find out today, but I would like to find out sometime next week because that seems very interesting.
Yeah, probably some trait for that. Yeah, but that's what the question mark does. So because now this function,
you know what would be really awesome?
Yeah, tell me.
A Rust shortcut guide.
There is so many things to explain. So many. Where to start, where to end.
Like, it wouldn't even necessarily, okay, maybe not a guide, but like a lexicon or just something that puts one thing on the one side and the other thing on the other side. And the explanations can be super brief just to have something to look up.
If you can write yourself a text file or something on what you know, more or less, roughly to get myself an idea on what you want, I might be able to complete it or make it right.
Okay. I will give that a thought next week.
So now you understand that this function returns from the option, always returns none for all invalid input. As when the input is invalid, it returns none straight away. Okay, and it returns some only for valid input. So because of that, this special syntax of the while loop, okay, this you might not be aware of this syntax. You are aware of the loop syntax.
Mm-hmm.
This is basically is an you know what this does? The let sum, if let sum. Or I'm asking already too much. I'm going.
If let sum is equal.
You know what? It's even that is not going even to work. By row. Let's call it cur for now. You do something like, so you get the option, okay? Cur as in current. If cur is none, break. Then we did sum 3, so then let 3 equals cur unwrap. Okay? This from here to here, that is this line here. And then you copy and paste this inside, and this is the code of the while. That's what it does. So basically, while let sum 3, so a while loop is a loop that loops until as long as some condition is met, right? So as long as what you put in here returns true. You can do while true, that is just a loop that keeps forever looping. Or you can do while a minus less than 5, a minus equal 1, and that will loop and remove 1 from the variable until it no longer meets the criteria, and then automatically breaks. That's a while loop. That's a regular while loop. Okay. So
long story short, while is loop with an if condition?
Yes. While is a loop with a if condition that does the break. So, and this is the reverse of the break. So if you have this while, the loop represents as if not your condition, this condition, break. That's the transformation that it does. Okay, so as long as it's true, it will continue looping. As long as this is true. When it's false, it will catch the break. That's what it does. So while means while a is less than 5. So as long as a is less than 5, you just loop until that's no longer true. Okay, that's what it does. So, but the while let sum syntax, this is a while, that's called a while let. Is the while let syntax that is Rust specific. And there is also the if let syntax that is also Rust specific. Okay, but let's focus on the while one. That's the one that we are using. What it does is you pass. You are trying to get an option into sum. Okay, so we are trying to unpack it. We're trying to unwrap it. This is trying to unwrap it. So this is saying unwrap it. You just unwrap the option until you cannot. When you cannot unwrap it, break the loop. So like this. So you get the option. Check if it is none. If it is none, you cannot unwrap it. So break the loop. And as long as you can unwrap it, you just unwrap it. So it's saying unwrap it as long as it's possible. And when you reach a state that you cannot longer unwrap anymore, instead of panicking, just cut the loop. Break from the loop.
That makes sense.
Okay. So this is what the syntax is doing. It is very, very convenient to write. It's very, very convenient. And it works not only with enums, it works with any kind of enum. You can do also let something that returns a result. So function result, something that returns a result, you could do as long as you can convert it into an OK value, as long as this returns an OK, then continue looping. And then the additional benefit is that not only checks that, the contents are being unwrapped into a variable that you choose. This is the variable the variable name that you define. So you put 3.1 here, needs to be here because this is the variable name. Here you are defining the variable name. Good?
Yes, all good.
Good. a lot we are learning today, a lot. So this is the good thing of me also driving, because I can teach you and explain a lot of advanced stuff that by yourself this is more complex by yourself, and myself on only voice and chat I cannot explain myself enough to make you write this kind of code. It will be very exhausting because you don't know the syntax, and going letter by letter is very exhausting.
I agree.
Once you saw it 2 or 3 times, you will say, whoa, how is done? And if you know the name is an while let syntax, you Google this, it will give you examples for sure. While let or if let syntax. So basically we go one up, and then we try to get the tree that is one up, and if there is some tree, then we print it, and then we try to go to the above. So we point to the above, and then it loops and tries to get that one above that we just moved the cursor one above. So now we try to get it. And then if that succeeds, we continue printing. If that fails, we stop. So basically, this is a cursor that keeps moving up and up until it reaches out of bounds. In this case, until it reaches 0. But going down, this is more helpful because it will detect when the vector has no more options, no more items. Because we are going below, like down, 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 until we fall out of the board. When we fall out of the board, we do know that, so this returns none, and we know that we are out of the board already, and we stop. And this is very practical. And doing left and right is mostly the same thing. So going left is basically we go column -1 and column -1. Mutable needs to be called. And that will go left. So you start in the same row as the treehouse, but one column left from the treehouse. And then try to see if that is valid. And if it is valid, print. And then continue going left and printing until you fall out of bounds.
That is amazing.
And you can go right.
It seems to me that you are pretty much done already. Because what's left after that? Finding the product of the sum.
No, the product is done. You need to complete the contents. There is logic still to be made. That needs to contain something. You need to count. So basically, the scene. Okay, I'm going to do one thing more so we are not confused at all. So we need to write 4 things. We need to write the up score, down score, left score, and sorry, this doesn't work in Rust. In C you can put you can declare variables in comma one after the other. In Rust no. In Rust you cannot do that. Up score 0, 0, 0. You can change this later, okay? I'm just trying to make sure I'm placing you in the right track, so you compute the right thing. Those will be probably mutable later if you want to change them, but then basically at the end, once you have those scores computed, here is basically up score, down score, left score. It doesn't matter the order. Okay?
Okay.
Then the problem is that if we are going up, you need to compute here that. And then if you can compute 1, then we can see how to translate to the others.
And the computing you leave to me?
I was hoping so, yeah.
Okay, sounds good.
Okay.
Save image as image.png. Did you not save the image? What? Save image as image.png. Please save this time. Yes, replace. The image failed to save. Okay, you did give me the link, right? I'm gonna copy link, put it up in the browser. I just have to find it again. There it is. Oh, looks a bit different. Copy of sheet 1. Okay. Good. Okay, up score. Height. What is the height again? The height is not red, but you initiated it, right? You did initiate it.
Yes. Self.height contains the height of the treehouse.
What height? While let sum get 3 option self.height. Let's see, can I print this? But wait. Hold on. Can't we remove this let mud?
No.
No, why not?
No, because it needs to change. You're bothered about the redeclaration?
Yeah, like why do we need this?
Because basically I want to copy paste the same code. I want the code to be exactly the same. And so it's a new row 1 call that starts. So we are resetting again from the treehouse position to now to go down. So
But why? I don't get why not reuse the same.
It doesn't make any difference for the code, and you might get more likelihood of bugs if you start removing it because you can remove it. In fact, I'm thinking something to remove a lot of code here. I will try later about an iterator that creates this this logic that they created here to move it into an iterator later. But your code inside will be the same.
Okay.
So yeah, I mean, I don't want you to care about the going down. So I want you just to fill up the going up. In fact, we can even comment out. I'll comment out quickly all the other things because we don't care.
Okay, let me know when I can continue.
Yes, there. Just on the compute the up score. That's the only thing we want to do.
It's not giving me warnings anymore.
No, because the code is fixed.
No, like I mean it.
Not in my computer either. I don't see any warning.
So it's white for you?
Yes.
Okay, good. Self.height, yes. Okay, let us try to print a sample, yes. Height is That's wrong.
No, it's not wrong. It's because it's the end of the program and it's analyzing the treehouse at the bottom right position, which has height 0. If you scroll up on the console, you will see that it's analyzing other options, and you will see other numbers.
Okay. That is okay. Nice.
It is analyzing all 25 positions already. You have already a for loop that iterates through all 25 positions possible. So it is constant. So for this function, self.height is constant for this function.
Nice.
Okay.
That is
because this function is called for one possibility of the treehouse, which simplifies the problem. You only have to care about, we have one choice of a treehouse position, we want to know the score. That's all. And then the remaining code will work out for you the total scenic value and the maximum one.
Okay, I need to recognize this, but I also need to count the last 3. So I need to make a bool here.
Why do you want to count the last 3? The last 3. I checked the description like 3 times, and it clearly says that you only have to stop counting trees as soon as you find one that is higher or equal to the treehouse height. It doesn't matter.
But that tree needs to be counted, right?
Yes, that tree itself needs to be counted when you stop. But if you find, for example, a tree of value 2 and then a tree of value 3, you continue counting. And in the reverse, also the same. You count 3, then 2, you keep counting. You don't need to keep track of the past 3. You only need to keep track of the house height, which is self height, and the current height that you are looking at of that tree.
Okay, so greater or equal than self.height break.
Okay.
Thing is missing though?
No. Well, something you have something. The code is valid. You're missing a line of code, I guess.
Yes.
But these are master.
Up score. We are currently at up, going up. Yes. So up score plus equals.
It's just +1. Every tree counts only 1. It doesn't count by the tree height. It counts 1 because it's one tree counted. The score is the number of trees, not the sum of the heights.
Okay, then wait. And I'm... Oh yeah, okay. So plus... Wait, there was a shorter syntax for this, for plus plus?
That's C++.
So not here, okay.
Yeah, C and C++ place the plus and minus, and both Python and Rust have removed the syntax because it's error prone.
Mut.
Okay, let's give it a try to everything together. Can I?
Okay.
I'm going to put both together because it's easier to copy and paste. And now, sorry, here. This is down score. This is left score. This is right score. And if we didn't make any error between you and me, I think that should be correct. And I'm going to comment out the debugs. That is a lot of debug that we don't need. And something that I would like to see, that's why I'm removing the debugs, is because I would like to see the total scene value. I would like to see the component of the scene. I would like to see the debug. In line 145, I'm adding the debug of the self scene to see the scores, individual scores. Okay. 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 Max scenic value is some 8. But there is a problem. There is a problem. I mean, this might be correct. The problem, because it matches, but the problem is that we don't know the position of the winner. And,
do we need the position?
No, we don't. But in order to debug, it will be interesting to see which one has been selected. So I will like trees iter map x. So let me do it something different. So we have some debugging power here. X dot row comma x dot, or just x, then max by key, and then the key is x0. Yes, and then this returns not an option U64. This returns an option something, which is U64 ampersand 3. Yes, U64 and the reference to a tree. And now, parenthesis. This is a tuple. Yeah, and now this should tell us not only the score, which is 8. It tells us that this was row 3, column 2. So actually, this is 0 index, so it's 4th row, 3rd column, with a height of value 5, and the scene score was 2122, and this matches the example. Because it was in column 4, the middle 5. Sorry, row 4, middle 5.
Can you in the debug make it so that it will display the actual number and not the not the internal number, but the represented number?
I mean, isn't the first number being printed, right? The first 8 is the score.
No, I mean like row 4 instead of row 3.
Oh yeah. This is. Let's do an if let max. Sorry, sum max equals max scenic. So this is basically if you can unwrap it, we want to do the drawing th is max dot 1 dot is that 1, right? Yes. Why are you row? Yes, plus 1. So let's print this first, and then let's put the winner house. At row call, which is row nth call nth, with a height. We're going to forget.
Going all out here.
Yes. max.1.height. And the scenic score value of this, which is max 0. Yeah, 4,3, 8 of 5, and a scenic value of 8.
Okay.
We can go to the problem and you can see that this is what it's saying. So in the second approach, it has picked the 3 of height 5 in the middle of the fourth row. So it's 4 and 3 is choosing that one. And it's doing 2, 2, 1, 2. And in our case, 2, 1, 2, 2, because they are doing in a different order. But yeah, that doesn't matter. And the total is 8. Okay, did this print a lot? Line 145 is printing. We need to remove those prints. This is the cool thing of having a debug. Because it tells me the line, I know where I need to go and remove. I'm going to remove. Because I want to do the full thing.
Is there an equivalent for the debug macro that only debugs when a certain
yes, there is a crate for that. There is a collection of crates for the Rust log crates that can enable or disable macros. So, are you following me on the cursors? You can see what I'm writing,
yes.
Right? So, it creates some macros like info that, and you can put here like in println, something like that. Okay. And it will do info colon in and put the text. And there is info, debug, warn, error. I think there are with different levels. And then when you call the program, you can put an environment variable. And with the environment variable, you can say, I want info, I want debug, I want warnings, and it will put only those levels and above. So if you put info, it will do info, warn, and error. If you put warn, it will do warn and errors. So it can regulate the amount of output you want from the program.
That is nice.
Very nicely, yes. You need like 2 or 3 crates for that joint. But it's very nice. I have used it in Yarosco. Yarosco uses that.
I see.
Because, I mean, you need proper logging. You need a lot being printed, but you need to be able to control to say, I want it or I don't want it, because for regular runs, it's too much. Okay, let's try it.
Crossing fingers. Ooh.
Okay. That is a lot of value. 60... 38, 23, 3. Of course, because you can count all the trees. It says that it counts. Okay, unless we misunderstood the problem and we don't need to count all the trees. But I assure you that I double read that like 3 times. And that's what it says. Doesn't make sense to me, but it's what it says. Therefore, going to paste it, see what happens.
Okay, show the browser, please.
Yeah, I'm showing the browser.
Okay, delay. I forgot.
Yeah, the delay, yes. Might be 1 or 2, 3 seconds, I don't know, maybe more. More, okay. I'm sorry. Yeah, I'm going to submit my end.
I'm seeing it. We'll let you know when you click.
I clicked. I'm waiting for you to see the result.
Yes. Click. Gold star! Awesome! GG!
Yeah. Okay. Now that we finished, I want to try something with you. Well, I mean, I'm going to code it. This is going to be too much for you. This is something that I'm learning to do, which is iterators, which is basically, I want to make this logic, this logic here, those 4 lines, into some kind of iterator. So I don't need. I
4
don't need
lines?
to. Yeah, 92 to 98. You need to go and follow me if you want.
4 loops, I mean.
Yeah, I mean, those will be still four loops. I want to keep the 4 loops, but the problem is that they have logic that is very easy to get wrong. Because you need to put the -1 in the same place, in the same way. And I don't like that. Because it's being repeated 4 times in a slightly different ways. The same algorithm applied in 4 slightly different ways. And I would like something that abstracts that away from me. So there is no way to mess it up. You understand what I mean, no? More or less.
More or less, yeah.
So what I want is to be able to call something like for 3 in self iterate move. Okay, so we need to iterate moves, and then let's call it this move left, comma ampersand tm, and then we will have this inside. And that will be way easier to read. Like, I want to iterate towards the left until I finish the board. And the same for the all 4.
I mean, I find it pretty easy with the comment already.
Yeah, yes, but I mean, we are in extra time, right? So why not try to learn something new? Because even this, we could create the vector straight away by creating a let directions equals vec of I don't know.
How much longer would you like the stream to continue?
Not much. I want to code fast. I'm not pretending.
Because I was wondering whether a 10-minute break would be good now.
No, I want to finish soon.
Okay.
So if we have, for example, something like even directions, we could do even a for direction in directions, and then just move in that direction, and then score equals 0, score plus 1, and then
what is this symbol? I see it the second time today.
Which? Oh, okay. Sorry, that's in my keyboard by mistake. So that's the key on the left of the 1. So sorry.
Okay.
So those are the keys on the top row, and if I hit, for example, alt graphic, I have the backslash here, and the arroba
I see.
or add. Okay, this is a symbol used in Spanish because we do this and that means number. It's for a termination of a word, so it means RO, because this number is número, so RO número. This is the row ending. There is another one for A, which is with shift. And that's, for example, for Maria, M-A, Maria Angeles. That's a name. So Maria Angeles. That's so common in Spain that we have custom symbols for that.
I had Spanish for 6 months, and I don't recall.
No, that's not it, because I mean you don't need it for speaking Spanish. That's part of the written Spanish. And it's also old. It's getting a bit unused. It's still used, but not that much as before. So yeah, so this is the idea.
Left, right, up, down. You're gonna make enums or
Yeah,
structs?
yes, something like that, or constants, maybe just constants, okay? But this is the idea. So we could do all the thing in just this code. Same logic again and again and again. What do you think?
Okay.
Interesting, right?
Yeah. I don't have anything to say because I'm tired and stuff, but I am observing. I am interested where this will go
Yeah.
and how this will go.
And that's also for me to practice making a better use of Rust. So
I was wondering earlier, during the your 10-minute break, I think, whether this could be done similarly to what you recommended to me in BY Ballistics. To have some sort of auto recognition about directions.
yes, that's the idea I'm going around. So self iterate move. Yes, that is here. Iterate move. We are going to read self. We are going to read self. We are going to read tree map, because that's what is going to be iterated. We might
I have a feeling where this will be going.
Move iterator. And here is the problem. This needs lifetimes.
Oh shit, why?
Because iterators need lifetimes. You need to borrow the whole time. That's why I want to do those things, because they are interesting.
Did I use lifetimes in BY Ballistics?
I don't think so. But actually, I might not need to specify the lifetime, because it can hold to both the same lifetime. I don't think we need to specify the lifetime here. So yes, that is to do yet. And now we are going to create the iterator. And the iterator has an origin, which is a reference to a tree, which has the row one call.
Mm-hmm.
No. It has the current one. It has... this will be iSize, because it's going to be convenient already to be iSize, which is the current one that we are going to return. It needs a direction. iSize, and let's write some constants. Left. I could do this better, but I mean, I don't want to spend much time, and this is good enough. So left is just -1 on the x-axis. Sorry, we are going. This is row call. So this is y and this is x. So 0 on the row axis, -1 on the column axis. And that should be uppercase, because it's a
It's a const.
So, and with the format, a lot of times I don't agree, like you, but I do.
You don't agree about consts being...
Sometimes I would like to have them, or sometimes I don't agree exactly with the formatting, but I have suffered what is the result of having custom formats and everyone doing a format that they like. And I hate that so much that, okay, whatever you say is the format, I will agree, because at the end it's just names. It is
That's
just
kind of
nice.
how I feel about snake case.
About the
It,
snake case, yeah. I don't like, for example, the Java approach of naming that is using the camel case everywhere. I don't like it because I got used to the snake case. But yeah, as in Go, in Golang, they also go with camel case syntax. And I don't like it, but that's minor because if each program has this different syntax, is the problem.
I do like that Rust uses a variety.
It makes quite a lot of sense to me. I like it. I like it a lot.
Camel case for types, a snake case for variables, capitals for constants. This is good. This is good.
I can even do a type def direction is isize, isize if you like. Type. Yeah, sorry.
What language is type def?
C++. That's exactly the same.
Good to know. Good to know.
Exactly the same. The syntax is very similar syntax. It's slightly different. I think that in C++ is type def direction int or something like that, where you put here directly the other type instead of equals, so there is no equals. But C++ doesn't have tuples. You cannot do that in C++.
Doesn't it have tuples in the standard library?
Yes, but that's not a native type. Yes, yes.
Oh,
yes.
so it can. So type def only works with native types.
No, it will work. It will work. It's just that I don't know the standard library, so I cannot tell you what is the syntax of that.
I see.
So yeah, we have the direction to move.
Oh, yeah, because your C++ is C with classes.
Yeah, exactly. You got it. You got it. Key thing on iterators. Never derive clone on iterators. Well, no.
Never derive clonal iterators?
No, never derive copy. Sorry, never derive copy. You can derive clone, but cloning an iterator is a risky move. So you need to. It needs to be. That's something that someone told me. Like copying.
I generally like to derive clone, but not copy.
Yeah, copy on iterators can lead to unexpected behavior, because it can make copies when you don't expect it to, and mess your iterator. And your iterator, instead of moving forward, it's resetting its time and creating a lot of copies by mistake. I need more stuff. The iterator needs the tree map, which is the reference. And now, this needs a lifetime. And now you need to define the lifetime here. So this is just to define the lifetime. So this is saying that this is generic over the lifetime A, which is for this. This is basically saying that you need to store this struct in memory at least as long as this tree map is in memory. You cannot free the tree map that is referenced in here until you destroy this one. That is what is saying. You cannot free the memory in this pointer until this one is freed. That's the idea.
That makes sense to me.
Yeah.
That's what I used in day 7?
Yes. Yes. It is an iterator like this one. It's the same idea.
Will I need a similar idea in C++?
C++ doesn't have lifetimes. It's just that because it doesn't have lifetimes, you have to care about that yourself. So when you store a reference into something else, you need to be careful of not freeing the actual value before removing all the references. Because if not, it will explode.
Okay. So basically, it will be my first experience with memory allocation after all, even without unions.
Yes, you have that in C++. If you are using pointers to something, you end having this problem. So yeah, here you have the compiler Rust telling you that you are a complete idiot, and in C++ it says, yes, all is okay, and then the program explodes. Sometimes, maybe not always, and that's the hard part. So we implement...
I prefer the Rust approach.
Yeah, I do too. I hate this syntax that when you implement over something generic, you need to define it on the left and then use it on the right. I hate that. But
can you explain the syntax a bit to me?
yeah, so you want to implement over this struct, right?
Mm-hmm.
So you begin with this. Okay. Now the problem is that this one is generic over a lifetime. So first it's going to tell you that you cannot implement over nothing. You need to implement over a particular specific lifetime. Okay. So doesn't want to fix. Okay. Doesn't want to fix. So it will say you need to put here the lifetime, and then you put the lifetime. And then the problem is like, yes, if you put the lifetime here, you need first to declare the lifetime that you're using. How many lifetimes or how many generic parameters? If you put anything, a type, a lifetime or something, you need to declare it first. And to declare it, you put it here. So basically, this is saying like, I'm going to implement something generic over this lifetime. And then this is a struct that I want to implement over for this lifetime. So this is the definition, and this is the use of the type or lifetime. In this case is a lifetime. It's a bit redundant.
Is it always this character and an A, or can it be something different?
Lifetimes have this character. That indicates a lifetime.
Okay, and what is the A?
Anything. It can be even many letters. There is also the lifetime static. There is a specific lifetime called the static. You can name it Z. I can do that. That works. It doesn't need to match this. So this A at this A needs to be the same, and this Z at this Z needs to be the same. And then this Z and this A are the same because they are in the same place, in the same order. This is the first argument, and this is the first argument. So therefore they are the same. So I can rename it here, no problem.
Why do you need to put it twice if it's the same?
Yeah, I have the same questions as well. So I understand that the left one is the definition, saying that I'm going to use an implementation over something generic, and those are the parameters that I'm going to use. I know that this is the definition, and the right side is the use, the part when I'm going to use them. But I think they should make the language accept this, because it's not ambiguous. It's not ambiguous. There is no other way. So
yeah.
I do not understand why. So I'm telling you what I know. What I know is that left is definition, right is use. Why?
Where can it be at another position other than the right?
I don't know. Seriously, I don't know. I mean, there is some syntax called where that I'm not fancy about. I haven't learned about it that much. That you can use also other lifetimes and so on. But it's mostly the same. It's a different syntax for the same thing. So, I don't know. Okay, I don't know.
Nice.
There is a lot more into Rust that you and me know. So maybe there is some particular reason for consistency, which I'm not sure. So wait, I can implement first here. To create the iterator, tree move iterator. No. This is owned. This is owned. This is owned. This is owned. This is self row. This is self call. The direction needs to be a direction that I need to pass. Direction is direction. And this is TM. This is the same. And this now gets converted as eSize and as eSize or iSize, whatever it's pronounced in English. Now we do have a problem here, which is yes. Now we have a lifetime problem. Cargo check. Let's read it properly. And it's telling me the answer. So there are two references. And the problem is that the value that we return contains a pointer to something, because it has, you remember that here on top in the struct, we say that this has a lifetime. Okay, so this contains a reference. So Rust needs to know to which argument do we need to tie these to. Do we need to tie this to the tree map or to self? Because both have borrows, both have the ampersand. So it's saying like, let's call this lifetime of the reference tick 1 and the other one tick 2. Okay, so associative function was supposed to return the data with lifetime 2 with self, but is returning data with lifetime 1. Help. Consider introducing a name lifetime and update the thread if needed. Yes. So basically saying that I need to be specific about the lifetimes. So I need to pass A, and this is A, and this returns over A. Can I say that this is not named? Yes, that also works. Better. Because the problem, if you're following my cursor still?
Yes.
So if you do this, the return value, okay, will be borrowing at the same time self and TM at the same time. So you need to destroy the iterator before you destroy both self and the tree map. Okay? But if I do this, and I remove this A here, now we are only borrowing the tree map with the iterator. We are not carrying self. So this is the problem. After you call the function, so this function that takes a borrowed self and a borrowed TM, the borrow is outliving the function. After the function ends, the borrow is still alive inside the struct. And until you destroy the struct, the borrow is there, and you cannot, for example, create a mutable reference to this tree map if you wanted. That creates restrictions. Okay, but maybe it's too much. Maybe it's too much. I'm not sure. But
I mean, it is. I definitely won't get this today, but so I already made experience that I don't have to understand stuff immediately to get more familiar with it. And if the stuff goes through my head again and again, then I'll get it eventually. Can you maybe type out what you just said? I would like to say it myself.
Oof, to type it out. So if I've left them for a self and a tree map are at the same time, the borrow will so first when returning a struct with a lifetime, like this thing, the borrow will outlive the function, meaning that it will not cease to exist until the struct is deleted, freed. Okay, now if both self and tree map have lifetimes at the same time, will happen for both, meaning that also self cannot be mutably borrowed until tree move iterator is destroyed. However, turns out that we are not storing self or any of its contents as a reference in the struct. So the borrow for self can finish when the function ends. For that, we remove the lifetime from self, leaving with just self. So this one is free to use in case we want to later, which we don't, which
we don't need, but whatever. Nice.
okay. So yeah, I'm just trying to hold only whatever I need to hold, not holding too much. Yeah.
Want to read for myself now?
Yes.
When returning a struct with a lifetime name, the borrow will outlive the function, meaning that it will not cease to exist until the struct is deleted freed. Lifetime. Returning a struct. Both times at the same time, the borrow will happen for both, meaning that also self cannot be mutably borrowed until the remove iterator is destroyed. Both a self and a tree map. However, turns out that we are not storing self or any of its contents as a reference in the struct. So the borrow for self can finish when the function ends. For that, we remove the lifetime from self, leaving with just self. So this one is free to use just in case we want to later, which we don't, but whatever. I feel this is a pretty good description that you give here, and I think you should make an isolated example case with it, where you rename all the relevant stuff into a more simpler context.
At some point, I'll try to make a stream about this, about lifetimes. I need to prepare because I'm not that fond of them. But yeah, I should do a stream about this. I'm going to point two things. So the first phrase, you had already a problem. When you call a function that expects this, a present self, let's say that we call, I don't know, okay, self, iterate, move, whatever, okay, self is borrowed, okay, you are borrowing self to do that, okay. Let's move below. Let's say another function. Do we have another function? Total ascending value, this one, okay. So if you call this, okay.
By the way, do you still got the number of the results in your clipboard?
The results?
Yeah, or in the terminal maybe. Let us scroll up. Like the result for day 2, I mean.
It tells me, I think I can go to day 8.
A scenic value of 157320.
I have it in the web page.
Okay, I'm gonna copy and paste in Matrix.
It's different for each person, you know.
I know. I didn't mean to add that to my end.
Yeah. Yes.
Oh fuck!
You
I can't copy in your chat.
You
Yes,
want
yes,
to check.
to check your new algorithm, exactly.
Yeah.
157, 157, 320, 320. Okay.
Yeah, I have it. I have it as well. No worries to do the check. So follow me for a second. So when you call with
Hold on. Want to put the VM up? Okay, following.
yeah, when you call something that is accepting ampersand self or ampersand something as a parameter, basically you are doing a borrow of self and then calling self total sending value.
Is it accurate to say that when I borrow a console of a friend and I put a lifetime into it, then I am legally obligated to destroy the console before giving it back?
No, your friend cannot destroy the console until you give it back. That's the correct one.
Oh,
That's what the lifetime is ensuring, that your friend is unable to destroy the console until you return it back.
wait, didn't your description say, returning with a lifetime, the borrow will outlive the function.
Yeah, it means that you pass the parameter tm as this function, okay? And usually that borrow will end as the function end. When the function finished its work, it's no longer borrowed. You can do whatever with it, okay? But because we are storing the borrow in the struct, okay? Now the function returns and the item, the console, is still borrowed. Is borrowed inside the struct. And Rust needs to track that.
Is lifetime having the console borrowed even when I don't use it anymore?
It's like the friend returns your console, but the console needs to go to the shop for repairs, and you cannot sell the console or destroy the console until it goes to the repairs. There is something missing yet. There is something pending. There is something pending on that, and it's
I feel it needs a better analogy.
Yeah, it needs a better analogy. But yeah, the borrow usually ends when the function ends. That's what normally happens. But when you return a struct or something that contains a lifetime, this lifetime is going to make the borrow outlive the function, in the meaning that the function, after you call the function and has completed, you can still not do whatever you want with your original item. You need to finish with in this case, with the iterator before doing anything with the other stuff. This is more or less the idea. So, to put it in other words, or more like in C++ words, tree-move iterator contains a pointer to a memory address where that should contain a tree map, okay? While you have that struct with that pointer inside, if you by accident go to the tree map and modify it, copy it, move it to a different place, or just delete it by accident, any access that you do with the struct that has this pointer, the pointer will be dangling, will be pointing to nowhere, to invalid memory, and the next access that you do will just crash the program. That's what happens in C++. What happens in Rust is that at compile time, it checks that you cannot do anything with the original tree map until you finish and delete the tree-move iterator, because it contains this pointer. Okay. And the last thing is that this is also syntactic sugar, because in reality what is happening is this. This is a lifetime called B and B. Okay, so basically meaning that...
What are A and B in this case?
Two lifetimes, okay? There are two lifetimes. Lifetime A and lifetime B. Just, they have names. You can put the name that you want, okay? So basically what we are saying is that because self is lifetime B and lifetime B is not in here, is not in this tree move iterator, then self is not going to be tied, that self lifetime, so the reference is not going to be tied to the struct because you don't have B here. If you had B here, it will be tying self. That should fail because I'm storing A. I need to place A here. If you put A and A, then what happens is that it is tying both borrows into the struct. Both variables are being borrowed by the struct at the same time. And removing the lifetime is just telling Rust, like, this is a different lifetime, name it however you want, I don't care. Like, it doesn't have any name, why do I need to name that? And Rust internally solves that. So the majority of cases, so in any function, if we go to the compute scenic value, internally, this has a lifetime, call it A, as you call it lifetime 1. Okay, it doesn't matter.
Okay.
It doesn't matter. And then there will be lifetime 1 and lifetime 1. That's what
That's often hard for outsiders to recognize. Okay, is this some special call or is this a variable? When using single characters, it's not immediately obvious.
Yes. So this is what it does by default. Internally, it's doing that when you don't put anything. Or not exactly this, but it's doing an automatic magic to do a guesswork as long as it has to be correct. So there is a lot of work that they put into this guesswork, so it cannot do something unexpected in the lifetime. So as soon as there is possibility for confusion, it will require you to write the lifetime down, just to be sure that you are doing what you want to be doing. But yeah, that is what is happening here. So today you know a bit more about lifetimes. You still don't know how they work or what they are, but you know a bit. You know a bit already.
Yeah, I know. I am less unknowing than before today.
That's the spirit. So now we want to implement here. I want to implement an iterator. So I'll go to the browser. I'll do Rust implement iterator because I never remember how to do it. I have Rust by example. I'm going to copy it quickly. It's just implement iterator. Okay. Implement iterator for this. And now implement. This is
iterator is always with lifetime, right?
Yes, I mean, an iterator will have most commonly lifetime. But it's not because the trait requires your lifetime. It's because when you're iterating over something, you need the elements to be accessible. Then you have a choice. Do you clone all the elements into memory of the iterator, or do you just reference them, borrow them? So because usually you want to borrow them to be cheap in memory and be fast, because a borrow is just copying a memory address. If you want to do a clone, it has to clone all the internal components, all the internal memory, which could be depending, no? So, hey, we have a viewer. Hello, Tommy Luco. Good morning, good night. Well, here is good night.
Okay. I will probably see in a bit. I'm gonna open Chatty. Okay, I see now. It's very small though. I have to increase
11 p.m.
size.
there? I mean, where are you? Because this is the same, I mean, Dublin, Ireland, and 11 p.m. that should be either Portugal, UK, Canary Islands. You live in Ireland. Okay, so we are in the same country. Huh. Okay, welcome. In Waterford. Nice. So here we are doing Advent of Code. We finished already, day 8. I'm going to just try to make myself look nice by implementing an iterator that is a crazy iterator. That's what we're doing today. So, what is I'm using? Through the Linux stack. Nice. I'm using Debian. I always run Debian testing in my computer. So when we're implementing the trait, okay, this is what will allow us to use the for loop automatically. Okay.
Hold on. I got a bit distracted. I have thread open now. Good evening, Tommy Luco. And
rare thing to see nowadays. Yeah, so many distros. So yeah, this is the iterator trait. Okay, by implementing this, if you follow me with my scroll, this allows us, when doing this here, you see that I have here the for tree in self-iterate move, placing this into the for loop.
Yes.
So by the struct that it returns, if the struct implements the iterator trait, the for loop will work. The for loop works if this returns the struct, if the struct implements the iterator. And the for, what it does is it calls the next function that we have in the iterator.
Wait. Iterate move. Function iterate move.
So to put it differently, this returns the iterator, and the type of that is no. How is called again? The tree move iterator. Okay, so as long as tree move iterator implements the iterator trait, the for tree in iterator will work. Oh, it's not up. What? Should be up. Okay.
Type item.
Yeah, but the basic idea is that the iterator the iterator trait is to be able to use this struct in a for loop. So the for loop can iterate through, can consume the items. Like, imagine like this was a vector, okay? It's a vector, but it's a vector that is generating the items one at a time. Instead of having to compose a full vector, we are going to return the items one at a time, and the for loop is going to return those one at a time without creating a vector in memory. That's what the iterator trait is doing. Is going to do. Right now, it's not doing it, of course.
Okay, so
yeah, no.
So what do you do now?
So first we define what is the item type. So like the for loop, what is returning the for loop in each iteration. Tommy Luco, just read your LTT data loss blog. My thought generally about LTT is that they have no real data specialist over there. Yeah. From what I have gathered, Jake and Anthony are the ones setting up and maintaining their service, yes. Not to discredit them, but I think they lack knowledge for a big data project like this. Yes, and to be fair, I do also lack a lot of knowledge as well. I have my own experiences, so they are. But yeah, I mean, I also don't intend to discredit them in any sense. But yeah, that's more or less the things that I thought like is going to happen at any time soon from how they are handling it. Anyway, back to task. I don't want to get more distracted because I want to finish soon. It's getting late. So the item that we want to return is one cell, 1 3. Come on, I have it here. Get tree option. Get tree option returns an option tree data. So a reference to tree data. So what we return is a reference to a tree data. Okay. And now, how do we compute the next? So let's copy the algorithm.
Ooh.
So what we do is first we move the cursor, the current row and call, in the same direction that dir that we have in direction. Direction has from how to move. So then row now is self row. Self row plus equals self direction dot 0 and self call plus equals self direction dot 1. So that means that if the direction is left is 0 comma minus 1, so then it will apply minus 1 in column. You see? And if it is up, it will apply minus 1 in row automatically. Okay?
I do see. That is a very clever way of doing this.
Okay. So now we need to get this. Let's convert this into an if. Okay, because now we don't put the loop inside because for does the loop for us and it calls us for each iteration. Okay, this is self-tm get tree option self.row self.call. Okay, and if that returns a value, then we return it. So, and if not, then we return none. That means that we just return this. And the iterator is done. Because
wow.
Here is a trick. Because this returns none when we need to stop looping. Turns out that when you return none from next, what the for understands is that it needs to stop looping. For loops as long as it returns some. It keeps calling next, and as long as we return some, it will keep looping. And
I guess the same applies to OK and error.
Yeah, but this one works only with option.
But I mean, it's like the for in and the question mark. They work the same in this regard.
Very similar, yes. Very similar approach. Yeah. In fact, you can use question mark. The problem is that if you put question mark, that also unwraps it. And then you will need to do sum. And that will work. But that is just the same as removing the sum and removing the question mark. And then Clippy gets mad at me because I'm placing code that is pointless. But yes, you can use the question mark to exit early. And yes, the question mark also checks for none or error to exit early. Tommy Luco, I work on that sector and sometimes I want to cry when I see their videos about those projects. Yeah. But it's nice. I love seeing them. Even if it feels a bit cringe to me sometimes. I love seeing them and I like seeing those videos. Even it's a bit cringe. Let's move. So this is done. Now, what are the chances that this code does work? Team is already borrowed. No need to reborrow. That does work. Let's comment everything over. So I comment everything. And
oh no, so many warnings.
And the only thing remaining that can be here into the comment section. No warnings. No warnings.
What does Clippy say?
Nothing, because when I do Control S, Clippy runs. I can run in console, but
yeah, I would like to see.
Yeah, it's in console. Cargo Clippy, nothing found.
I have to scroll down. Cargo Clippy, nothing found. Awesome. Okay.
Yeah, I have said that Clippy runs on Control S on save.
So what will be the result?
Oh yeah, let's see. 157.320. 157.320.
3-2. Okay, 3-2-0. Yeah, GG, you have it.
Look how less code, like, it was simple to implement the iterator. It's not that complicated. The piece of code is very small. Creating the iterator is trivial, and using it, wow.
Yeah.
Wow. I need to keep doing things like this to create my own iterators for more stuff, because they simplify a lot of stories, a lot of problems. And you see the amount of code that they commented. How much code was here? How many pages we commented? Okay, it says in
like about half. Actually, about half.
It says in characters, 2,500 characters. Wow. Versus 400. So we reduced the code in 5 times. 5 times fold.
Nice. Very nice.
I'm very impressed. I didn't think that this will turn out so cool, so nice. I thought the iterator was going to be more complex. But yeah. So this is the iterator thing. So in the iterator, I do specify how to navigate the source data, how to move, and how to get the data. Then, so this is the logic that's encapsulated in next, and then the for just uses it. This is super convenient. It makes, also you remember that you copied my iterator for day 7, and that's all you needed. Once you got the iterator, it was super simple. That's the power of the iterators. That sometimes it's easier to code the iterator. I understand that working with lifetimes is hard. The iterator tried is not that easy. But man, once you understand, you make the iterators, and it's much easier to code. It's reaching to me a point that I don't know how to code without this.
I mean, that's good.
Yeah.
I hope I'll get there too sometime.
I think that if you are able to get into this, a lot of the complex problems, you can move them into iterators, and they will simplify away a lot of problems. So yeah. Man, I'm very happy. I am very happy. Okay.
So am I.
So for me, I'm finished. So I don't know. Let's begin round of questions. If you have anything before closing, if you want to ask anything about iterators or about life or anything.
My brain is already shut off. I took all the information in that I could get in. Okay, I have one question. When will we continue? Maybe a little foreshadow to day 9?
Let's see what says day 9.
Oh, I cannot open it here. Oh, I can open it here.
Yes, you can.
Ooh.
Robrits.
I think this was one of those that intimidated you a bit.
Yes, it has a states. Wow. Huh.
Okay, let's do this next week.
Yeah.
I mean, it's Sunday. I mean the week after that.
Yeah. How likely are you to be here streaming with me very early compared to today? Like, instead of going overnight.
If we set an appointment, early enough in advance, then very likely.
It's like after 2 p.m. or 3 p.m. Here is the thing. It's going. I would like to tackle it on Saturday or Sunday. Mm-hmm. And I'm going to be at home, but I'll tell you why I'm going to be at home. I'm going to be at home because I'm on call. Okay, I'm primary on call, which means I can get paid at any second. But also means that we want to get out of the house at 6 p.m. sharp, which is your 7 p.m. So by your 7 p.m. we need to be finished. Wherever we are going to close.
That is okay. That is fine by me.
Also
that might actually be nice to have a time where it's definitive going to end.
So we need to start early, We went today for how many? 5 hours. Wow. So we need to start very early. Let's plan it ahead. And also there is the other thing. I can get paged. So this means that if I get paged, I'll leave the stream running and you will drive.
Okay.
I will,
Okay, happy to do so.
I will mute myself and I will go over the page. But yeah, until I finish with the page, I cannot go back. That can be from 10 minutes, 1 hour. I don't know. If it goes very bad, I'll let you know and then maybe cancel it or whatever, or stop it if you don't want to continue by yourself. But yeah, usually pages should be, they are typically short. It's not the first time that I stream while on call. Most of the time they are.
So on Saturday you want to continue this?
Saturday or Sunday, yeah. In both days I'm on call, which means that I will be at home from 6 a.m. to 6 p.m. That is the on-call period.
Okay.
Yeah,
I'll have to think about the time at which I can already be available.
Yeah, you let me know what is the best time for you. You know my limitation, because I need to be at home. I cannot exit my home from 6 a.m. to 6 p.m. Doing a stream with you coding Saturday or Sunday or both, it's excellent time to pass time here doing stuff.
Okay. Then we'll make it work.
And we saw today that you can take control and continue the stream yourself, even if I'm not available. You can continue because I can click follow and you can be heard.
I will need to better prepare the setup though. Today was a bit messy, but also first time, so it happens.
Yeah. During next week, between Monday and Friday, we can try to beat without the streaming and see if we can. I don't know if you want me to open a live share session so you can try again and I don't know, debug it better. Let me know and I can open it so you can debug it and see if you can make it work better.
Okay, sure.
In the hope that next time that we start a stream, we
it won't take an hour.
It won't take an hour, yeah. My audio setup is my audio setup. I don't know what happens with the sound card. I'm just learning about it, about the quirks that it has.
I mean, worst case, we should be even able to have the call via LM. No, via phone. Via phone won't work. It would work if I was streaming, but not if you are streaming.
Element is going to work. Just worst case, I need to remember that I need to reboot the sound card and reboot Pipewire. I need to reboot both if it doesn't work. This is the first time that happened to me that I had to restart both. Sometimes it's just I restart one or the other and it always works. This time my sound was working, but Element was not working even after restarting it, so I don't know. Oh well. Anyway, has been very nice. I enjoyed it a lot, and I'm looking forward to the next one.
Same for me.
Okay, so let's close the stream. It's the end of stream card now.
Have a good night, everyone.
Okay, good night. Bye.